afternoon, and thank you for joining me. There is some very dangerous, severe weather currently developing right now in the Midwest and the Great Plains. We currently have numerous supercells that are developing. So far, none of them are tornado warned, but there are numerous severe thunderstorm warnings for large, destructive hail and damaging winds in excess of 70 miles per hour. There's currently a severe thunderstorm warning in Kansas. Severe thunderstorm warning for Elk County in southeastern Kansas. Okay, there we go. At 4:06 p.m. Central Daylight Time, severe thunderstorms located along a line extending from 6 miles southwest of Toronto to Moline to 9 miles northwest of Hardy, moving east-southeast at 30 miles per hour. Hazard, 70 mile per hour wind gusts and half-dollar size hail. Source, radar indicated. Impact, hail damage to vehicles is expected. Expect considerable tree damage. Wind damage is also likely to mobile homes, roofs, and outbuildings. Locations impacted include Independence, Neodesha, Fredonia, Sedan, Howard, Cedarvale, Altoona, Moline, Longton, Elk City, Dexter, Buffalo, Granola, Fall River, Peru, Chautauqua, Chautauqua, Elk Falls, Havana, Elgin, and Bolton. Precautionary preparedness actions. A tornado watch remains in effect until 11 p.m. Central Daylight Time for southeastern Kansas. For your own protection, move to an interior room on the lowest floor of a building. Torrential rainfall is also occurring with these storms and may lead to flash flooding. Do not drive your vehicle through flooded roadways. That's the first warning. I think there's a warning for some giant hail in one of the cells. One of the cells had very, very large hail. Okay, let's see. Now we got numerous cells forming. Let's see what the warning's for. The National Weather Service in Tulsa has issued a severe thunderstorm warning for northern Osage County in northeastern Oklahoma, northern Pawnee County in northeastern Oklahoma until 5 p.m. Central Daylight Time. At 4:06 p.m. Central Daylight Time, severe thunderstorms are located along a line extending from 6 miles northwest of Scheidler to 5 miles southwest of Kaw City, moving southeast to 8 miles southeast of Ponca City, moving east at 30 miles per hour. Hazard, 60 mile per hour wind gusts and quarter-size hail. Source, radar indicated. Impact, hail damage to vehicles is expected. Expect wind damage to roofs, sidings, and trees. Locations in or near the path include Pasuka, Scheidler, Burbank, Foraker, Personia, Webb City, Fairfax, Ralston, Granola, Big Heart, Sunset Lake, Apperson. A tornado watch remains in effect until 11 p.m. Central Daylight Time for northeastern Oklahoma. So far, there's only a couple severe thunderstorm warnings. There's one warning in Illinois right now. Let's see what it looks like. Not too severe. 60 mile per hour wind gusts and quarter-size hail. Spotter reported winds and hail, basically. Spotter indicated hail. Lumley got some pretty large hail that got a hail core there. But right now, nothing tornadic is occurring, thankfully. Alright, so again, let's go back to the radar. Okay, right now let's look. So this is the basically the hail core. There was some DBZs over 75. Let's go to Storm Prediction Center and see if there's any reports. Let's see if there's any reports. Yeah, a lot of hail reports. Quarter size so far. So Arkansas, Kansas. Yep, we got quarter size hail. Wow, I'm surprised there. I think this is from last night. Oh yeah, look at that. Surprises. Wait. Earlier today. So yeah. Huh. Oh yeah, that's the Dallas Fort Worth storm that dropped some pretty large hail in the Dallas area. 6 miles northwest of Nolan. That's baseball sized hail. Wow, that's the Dallas Fort Worth cell actually that affected the Dallas Fort Worth area. The western and southern portions of Dallas got hit with hail. Tarrant County. So Dallas didn't get any hail though. Like the city of Dallas didn't get anything. In fact, it went off to the southwest and it actually hit the the National Weather Service office in Fort Worth actually got 1.5-inch diameter hail. In fact, let me go to their Twitter page right now. Twitter DFW NWS. There we go. National Weather Service Fort Worth. That's the one I'm looking for. I think there's going to be a pic. There we go. Uh-huh. There we go. It's actually slightly larger than 1.5 because the outer edge of it. Okay, if you draw a line, this is the 1.5 line here, and it actually grazes just a little bit, and then the edge of the hailstone, actually goes off the ruler just a little bit. You could draw like a perfectly straight line. So this is 1.75. It's definitely not 1.75. It's right about, I would say, between 1.6 and 1.7. So yeah, it's pretty large. That's, I would say, about 1.7 inches. Because it's about, I would say, 0.1 or 0.2 away. So this is 1.75 here. So this is 1 inch. This is 2 inches right here. This is 1.75. That's 1.5. So I would say it's right about between 1.6 and 1.7. Trying to account for how much it was off here and off over here. 1.5, 1. It's always in fifths, so it's or 1 point or an eighth. So it's 1.5, 1 point, about 1.78 or 1.58. So it's right around 1.6 inches in diameter in the Dallas Fort Worth area. And see, that's about ping pong ball size hail. And of course, it was actually a spotter report. You could see how the storm went through. That's not where the office is. The office is actually in the Arlington area. The office is actually right in this area. I'm going to show you where the office is in relation to the hail that actually came down. There we go. I'll show you where the office is. So it's right here. So this is Fort Worth. It's Melody Hills, North Richland Hills. So it's just north of the Fort Worth area. So you see where that road? So it's right in this area, right right near the intersection of Interstate 820 and 35 West. So that is right here. Would it open up? Oh, damn it. girlfriend just called. Yeah, she actually lives in Dallas. So, or yeah. Come on, would you open up? Yeah, I'm trying to get the whole because that's the app that I use too. So they were right here, and boom, yeah, they were right in the hail core. No, they were right in it. Like the Dallas Fort Worth area. Try to if you want to see where it is. Haltom City is here. Melody Hills is here. Dallas Fort Worth is just off the exit, just off the exit. So the Dallas Fort Worth area, the office is right here. Boom, right in the hail core, right in the southern portion of the hail core. It looked like it was gonna miss. It kind of looked like they were gonna get grazed, but then the southern portion just blew up and went right over them. And look, and guess what that led to them? Yeah, and that led to this nice little this big piece here. Yeah, so basically, yeah, it's impressive. And right now I'm looking at the radar again. So far, so far so good. No tornado warnings. Oh no, spoke too soon. I spoke too soon. We got a tornado warning just north of Sedan, Kansas. We got a tornado warning. No significant rotation. We don't have like a cup. Oh, we got some pretty strong rotation. So far, it's pretty broad, but there's a portion of it that might be producing a rain wrap tornado. I'm circling that right now. We might have a rain wrap tornado in our hands. Yeah, we possibly have a rain wrap tornado in our hands right now. I'm gonna submit this to Facebook. Tornadoes, a rain slash hail wrap tornado. We got a possible. Just north of just so far has not been confirmed, but I think we're about to get a confirmed tornado. North of and that's me right there. Yeah. And look what I mentioned and look what I wrote here, guys. This is what I wrote. There. So yeah. I wrote this 11 hours ago. This was about this was actually what for them was about 4 or 5 in the morning. Sedan. Possible rain slash hail wrap tornado just north of. Guys, this is looking really, really bad right now for areas just north of Sedan, Kansas. A very likely rain slash hail wrap tornado. It doesn't look like it's a big tornado. It looks like it just formed. Just the name is so weird. Sedan? Can't, like, that's a car name. That's the name of a car, Sedan. There we go. And I'm sending it. No. Darn it. I wrote KA instead of KS. Darn it. There we go. And I'm going to show you the video. Of course, there we go. Let's see if there's what it looks like. I'm going to show you the reflectivity now. Yeah, it's hail. There's a lot of hail in there. Just hope it's not debris, but yeah, yeah, it's definitely wrapped in precip. It's completely wrapped up in precip. Just hope there's no debris. Come on, come on, come on. Okay, let's go back to velocity. Correlation coefficient. Thank God. No debris. No debris. Oh, thank God. So far, there's no debris. So it looks like it has not touched the ground yet. Okay, righty. So right now, no wait, just the northeast part of Sudan. Nope. Let's see that. Oh, thank God! It gusted out. Oh, thank God! Tornado. Radar indicator rotation. Tornado ping pong ball sized hail, or it says ping pong sized hail. They don't say ping pong ball. They say no, they do ping pong ball sized hail. Sometimes they just say ping pong sized hail, but usually yeah, it's ping pong ball. Okay. The most dangerous threat today, I believe, is going to be not necessarily tornadoes, but yeah, it is tornadoes, but more like spin up. No, tornadoes, but spin ups along the line. It's you're basically getting a line coming through with embedded supercells on those lines. So it's not like you're getting discrete supercells like you do in some outbreaks. These are more along lines, but you will get supercell development on those lines because the conditions are ripe today for the development of supercells. There's actually basically going to be a squall line forming, but because of the very strong lapse rates, there will be hail. It's like to my friends who live in Tulsa, if you want to see this storm, go just a little bit south. Let me see. One second. Darn it. Spelled the name wrong. Hold on. Alrighty, so yeah, this is where the storm is now. No, that's where it was before. So yeah, that's some large hail there. I actually have a. So I had some pea-sized hail during my last live stream I was doing on my phone. Apparently, there was some technical issues. I believe it was because of the weather. I probably should have. I should have probably recorded it then uploaded. But I want to kind of film it in the moment, and unfortunately, it didn't go through. And probably you guys were getting a black screen when I was filming that hailstorm coming through my area. It wasn't really. Yeah, it was a hailstorm. The first one, my phone died. The first cell, my phone died. I got some slightly smaller than pea-sized hail, maybe like smaller than pea size, but I did get hail. Second cell, I got about pea-sized hail, about the same size that I got the day I recorded the microburst. I mean, before any crazy warnings, before anything crazy happens, so far there's nothing going on that's like, there's nothing that's like else that's happening right now. I'm looking at the velocities and basically they're weak right now. There's nothing that's basically to be concerned about. I'm looking at Tulsa right now. The radar, I mean the one in Enid, in north central Oklahoma, and it's not showing anything that's very concerning at the moment. I am noticing what could be a couplet forming near the just north of Pasuka, Kansas. But this is the video I wanted to show you guys. Okay, this is the middle of the stream. I'm actually thinking about doing a live stream with another YouTuber. The reason my YouTube channel is called Severe Weather Center, why I don't use my name, is because I want to one day have this channel to be a weather channel where others can also forecast the weather. And it's not just going to be me. And I don't want to own this channel. Well, it's under my name and it's under the my first username that I created all the way back in 2012, Stormfan Lover. Yes, I created this YouTube channel back in 2012, 8 years ago. It was over 8 years ago that I created this YouTube channel. But I'm going to be showing you guys some videos. And I do have Radar Scope, but not on PC. I can actually go to Radar Scope and log in. I think you have to download it in order for it to work. See, you have to. You can only get it as an app. Radar Scope. Yeah. I have Radar Scope, but I have it as an app. No, it's basically a computer. Anyway, let's go to this video I wanted to show you guys. It's a three-part video, basically of me getting hit by a microbursts. You know, you know what? No. All right. There we go. That's the one. That's my old channel. I basically changed it. Videos. It's the one I'm doing right now. Where is the one that I basically did? It was titled, I believe. I should probably make it Microburst Part 1, Microburst Part 2, Microburst Part 3. You know what? That's a much better video. What in the world? I really need. I think I already titled Crazy Microburst Part 1. NYC Microburst. And the storm was not severe warned. That's the thing. This cell was not severe warned. There was another severe group of storms that was to my southwest. This cluster of storms was severe warned in New Jersey. It fell apart, like it just completely disintegrated. I was kind of being pessimistic. I'm like, because I'm so unlucky, it's probably gonna fall apart, even though temperatures were in the 90s. Because the sky looked so hazy and cloudy, I'm like, it's gonna fall apart because it's not sunny out. It's gonna suck all the instability out. And it looked like I was right. The storm completely fell apart. And then I was thinking, no, the sky looks dark. Something's gonna happen. And boom, it formed. I mean, I was thinking logically, okay, it's cloudy, but then it was so hot and humid. I'm like, no, there's no way this storm is just gonna fall apart like that, especially with all the heat and humidity. And then I started developing rain shafts, to my left, which is looking to my south, because I was looking west. And to my left was a rain shaft, and then looking ahead, I saw what looked like a gust front coming in, but there was nothing underneath. There was no precip. And I saw green and blue, and I'm like, something's gonna happen. There's like hail churning up in there. It's like it's about to just come. And this is when I started filming when I realized something big was gonna happen. And yeah, basically, right now, let me look back at the radar scope app. I'm gonna see if anything's happening right now. So far, no tornado warnings. There's a lot of severe thunderstorm warnings. There's a slew of severe thunderstorm warnings. There's a particularly intense cell heading towards the southern part of Tulsa. Well, actually, no, it's heading towards like the Broken Arrow. I believe if it continues on its current track, it's gonna be heading toward the hail core. Will probably head down towards hmm, probably southern areas of Oklahoma of Tulsa, maybe Bixby, Coweta, Salupa, Sapo, Sapoupa, and maybe just areas just south of Broken Arrow. So Bixby, Coweta, and there's another cell that looks to be having a hook. It's just to the west southwest of Ralston right now, and on the velocity, even though it has a hook, the velocities are pretty weak. It does show that there is some rotation, but not significant. But I'm going to be tracking that cell because I have a friend of mine who lives in Tulsa, and I'm actually planning on going storm. I was actually supposed to be going storm chasing, but with the coronavirus and the fact that I'm in school, kind of my plans had to change. So I'm changing to my radar site right now. I just changed it to Tulsa, and so far no crazy rotation, but save. There we go. Just give me a second. I'm gonna take a call. Alrighty, I'm back on. Um, I'm all gonna be titling them the same thing. They're all gonna be titled as microbursts. Just basically because they were microbursts, that in fact it was a microburst that hit. It wasn't destructive like some microbursts. And I think by titling it simply NYC Microburst Part 2, it basically oh, surprised. Oh yeah, I do. Yeah, save. I'm surprised that I'm gonna be basically playing, but before I play the videos, I wanna.
There is blue and green over there right now. We're about to get hail. And we're about to get some really
And yes, I geeked out like crazy. Like you would not believe how I geeked out. I mean, like, oh my god, like I geeked out like, yeah, like any true weather nut would. Like I just went bonkers geeking out. This is the video where I actually geeked out. I think I already showed you this. Um, basically, in fact, like it didn't like it wasn't like a ball where you could see a ball coming down. It it did descend pretty quickly. I think if I had a really high definition camera and I was like on a building, you would, or you were looking from a different angle, you probably would have seen probably what appeared to be like a rain bomb, or basically you might have seen something like this. I didn't see anything like that. This is basically a rain bomb, what a rain bomb looks like. There, it's about to happen. Hold on. Boom, you see that darker area, that rain bombs. They've always been happening. Like, rain bombs are nothing that are. Move over tornadoes. There's need this. No, this is actually not. Rain bombs are actually not. They're nothing new. Rain bombs are just called microbursts. They've always been occurring. They've happened in the 1950s, 60s, and 70s. This is what usually happens in the desert, where you have dry air with rainfall into dry air, or cool dry air descending. This is nothing that is unheard of. Well, yeah, they might, because yeah, that is true. They're going to get worse because of global warmings, but in fact, yes, they will. When a thunderstorm, actually, that there was a lot of hail in this one. This produced a lot of hail. It was actually hailing before the microburst even hit. Colder air could drop down really quickly. Not just rain, hail. Microbursts often bring hail with them. You could actually see the hail falling in this video. See that white stuff? That's actually hail coming down. The only areas where microbursts might not produce hail are in the tropics. Because in the tropical areas, microbursts are usually more wetter and warmer. Like, instead of having like the base of the cloud being at 10,000 feet like you would in the desert Southwest, because of how dry it is there. In a tropical area, the base of the cloud might be what 5 or 6 thousand feet, and the only reason you might have strong winds is because you might have, like in Florida, because the microburst might start at 30 or 40 thousand feet and blast its way down, and you could get some small hail in those events. Especially like there was one severe thunderstorm warning. It was April for golf ball sized hail. I didn't see any hail. It was to my west, but I saw like the darkest possible red on the Weather Channel radar, and I was really close, and those thunder was booming like crazy. And then I heard the boop. The weather. On the Weather Channel, you used to hear the the beep beep. The three tones that they would play, the blaring tones, and then it scrolled down saying golf ball sized hail and damaging winds in excess of 60 miles per hour. Usually for golf ball sized hail, you would also have winds in excess of 70 or 80, but for this one it was 60. It was April 2000 and actually no, it was May. Not April, it was May 2005. It was like in the middle of May that I went. In fact, I remember. No, that's. There we go. Maybe it's an archive event. Let's see. Yeah, you see that? May 2005. Let's see. Let's go to May 1st. Nope. There's no next. Okay. 2, 3. That might have been the day. Hail. Martin, Florida. That could be the event. Miami-Dade, Homestead. Nope. Homestead. May 4th. I think it was towards the middle end of May. It was in the Hialeah area too. 7, 8, 9, 10. Come on. 10th, 11th, 13, 14, 15. Okay, I think it was towards the middle end of May. Wait, 14, 15, 16, 17, 18, 19, 20. Might be getting close. Getting close. 21. Nope. See hail poke. Look at that hail. Look at that Florida report. 1-inch hail. Okay, Kansas. 22. 23. 24. 25. Oh, wait. No, that's not that area. 26. Yep, I think that was the day. Yep. Hialeah. Oh, yeah. That was the day. Public reported golf ball sized hail in East Opelika. Yep. That was the day. Right here. That was the day. May 26, 2005. I think that was my second or first day there. May 2005 calendar. I'm gonna look at it. And it was, which day was it? 26th. I think we left the 23rd, and we were there for about a week. I think I left Sunday, so this was. Yep. We actually went by car. No, we flew that year. We didn't drive. We went by car that time. Yep. I remember it was May 2005. It was late May 05. Hialeah. Opalaka. See how far that was from me. I was in Sunny Isles Beach, and I remember the thunder was explosive. And I remember the storm forming, and it was already thundering before the severe thunderstorm warning was even issued. I know Opalaka is north of Miami. I was pretty close. I was here. It was very close to where I was. And the storm took this path. And it collapsed as it hit the sea breeze. Yeah, it basically fell apart and just produced some very heavy rains where I was. But the core of it did go to the north. And then you could see the other, Hollywood got basically nickel-sized hail in Hollywood. Similar to, yeah, Hollywood. Tamarack. So it's the same storm. So that area, they also got golf balls at sale. Let's see. That's basically. So I was here. This is my area. I was here. So basically, you could follow the path. No, that was a different storm. Yeah, so there was a lot of hailers that day, basically. No, that was a different storm. But yes, it went into Hollywood. So basically went Opalaka, Hialeah. So the storm basically took this path. So basically, if I was a little further west, if I was like over North Miami, I might have seen some hail. Because I saw that the core of it was when it was like in this area. Let's see. Anything crazy going on now? Got a lot of severe thunderstorm warnings right now. So far, nothing crazy in Tulsa, thankfully. But there's an intense cell right now that's heading south of Tulsa. Kind of looks like Tulsa might actually get missed. Better call my friend so he can get a move on to intercept that cell, because I don't want him. Or no, it looks like it may be heading his way. Independence, Kansas just got blasted by strong winds. Here's the video I wanted to show you there. This is where the fun begins. Alright, so now that I got all this out of the way, I'm gonna now basically show you the first part. There we go. That's because, yeah, that's the Raycock volcano sunset effect. So basically, we're getting several things that should be cooling the planet. First of all, we're having volcanic eruptions. Second of all, we're having a huge decrease in carbon dioxide emissions. And third, very low sunspot activity. We're having three things that favor global cooling versus the huge, and that's all against the huge increase in greenhouse gases. Let's look at temperatures for March. March 2020, global temperature anomaly. And has it images? Let's go to images right now. And yeah, still going up, still up and up. Raycock erupted right in the late part of 2019. This is 2019 right here. The Raycock eruption had no effect on cooling, none. Maybe a little bit in the northern hemisphere. I mean, but the eruption did put a lot of sulfur into the stratosphere. That could be the reason we did not have a sudden stratospheric warming event. Could be because of the large amounts of sulfur dioxide in the atmosphere. But doesn't sulfur heat up the stratosphere? Because sulfur goes into the stratosphere and basically destroys the ozone. What sulfur does, it basically reflects sunlight back to Earth. So again, let's go to the first part. I'm trying to. There we go. Let's go back down. Here's basically the first part. Actually, no, full screen. Let's see if I could. There we go. I'm gonna try to do it 1080p so you guys can see it fully. Okay, I'm gonna pause the video right here and see where I'm not moving it around too much. Okay, you see this here. You can see basically the base, a little bit of a rain shaft here, thin little rain shaft here. Doesn't look all too threatening at the time. Maybe that's why it's better if I zoom out. Yeah, I think it's. You could actually see basically the sky. You can see a little bit of a rain shaft there. You can see the crane there. That's, I mean, to me, of course, looking there, I saw clear sky, clear sky, clear sky, clear sky, and some rain over here. But what got me intrigued was basically, okay, was basically looking at this. Maybe I should playback speed quarter. You see how the sky looked, yeah, like that. You could see basically that rain shaft there and how it looked whitish. It didn't look like it was gonna hail at that time. This is not when I thought it was gonna hail. Actually, no. It kind of did look like it might. It kind of wanted to hail. I did notice some blues already there. That's why I thought it might start hailing. And also I noticed flashes of lightning. But I didn't hear any thunder. There was like lightning flashing in the clouds, but I didn't see any or hear any thunder. Okay, now let's basically play back to normal speed. I think you might have seen a little flash there. Hold on, let's go back to like maybe point 12. Right about there's a little flash. Yeah, right there. So look at the little flash right around the point 14 mark. Or actually point 12. So a little flash there. I don't think I noticed it at the time. No, I think I was already noticing it. This is where I.
Just dropped down. Very strong winds about to form here. Very strong winds. I gotta call the National Weather Service right now. Tell them the microburst is about to hit. I can't even see it over there now.
Yep. And of course, I called the National Weather Service, and 2 minutes after 2 minutes on the phone, 3 minutes.
There is blue and green over there right now. We're about to get hail, and we're about to get some really strong winds. It's really raining hard right now. There is literally a wall of hail and rain coming in right now. This just formed out of nowhere. 2 minutes, just rain shaft just came right down. There it is over there. It's coming in right now. Really, really strong cell coming in right now.
And the reason the video ended was because someone I think called me as I was ending. Yeah, see?
It's about to get really bad.
And that's when somebody called me. That's when I was called. And then this happened.
Here it comes. Oh my god. We got like 40, 50 mile an hour winds right now.
That's me starting to geek out a little bit.
Holy crap. That's like 60, 70 mile an hour winds right now. Holy.
The reason I was saying that is because of the reason I thought it was gonna get so bad was.
Crap. That's like 60, 70 mile an hour winds right now. Winds right now.
Okay, you see that? Boom. Okay, You see how those trees are swaying? That's why I'm saying that's 67 mile an hour winds. Because I was looking further down and I saw the trees swaying around like crazy.
Holy shit!
Yeah, I cursed.
Oh my god! Oh! Oh my god! Get in! Get in! Get in! Everybody just get in! Get in!
Yeah, that's me basically.
Get in! Come on! Come on! Move in!
I was not expecting any hail
Go
though.
out!
The hail started right about.
Oh, we got hail!
The hail actually started about 5 or 6 seconds before I said it was hailing. There, it's already hailing. I don't know if you saw that, but it's already hailing. Bounce. You saw a little bite bounce? Right around the .32, .33 mark, it already started hailing. There we go. That was a bounce already. So about the .32 mark, let's do playback speed to .5. There. You see that right there? See that little piece of hail? .33. How it rolled? I didn't even know it was hailing. But that's why I kept the window open. I wanted to see.
Oh, we got hail!
It took me about 8 seconds to realize it was hailing. Right there. Boom. See that? Boom, boom, boom. What made me realize it was hailing was, I believe... Let me see what made me realize it was hailing.
Get in! Come on! Come on! Move in!
That was a pea-sized hailstone.
Oh, we got hail! We got hail! Oh, we got hail! We got hail! Oh shit, we got hail! We got hail! We got hail! We have hail!
You can see a couple of the stones.
We have hail! We have hail! Oh god, we have...
Oh my god. Yeah, that's me geeking out, okay? I'm even having a laugh about it. Oh. Alright, I fixed it, guys.
Have hail! Holy shit! Oh my god! Oh! Oh my god! Get in! Get in!
So let me replay those 3 videos, because... basically I predicted the microphone.
Oh man, here it comes in. Wall of rain.
Hold on. Let me check the Tulsa radar again. Alright, so let's basically...
Oh boy, here it comes.
Yeah, in 45 seconds, this is what this guy went looking like this. So this guy went looking like this. Okay. To basically this. So this is what it was looking at and literally there's no pausing in the video, and literally you want to look like this, so complete obscuration, not only 40 seconds. So look, this you can see everything.
Can't even see it over there now. Gotta
look, and now part 2, a couple minutes later.
There is blue and green over there right now. We're about to get hail. And we're about to get some really strong winds.
This was all one video if I did not stop the first video, the second video. This whole video would have been about 10 minutes, I believe. 10 minutes.
It's really raining hard right now.
Because I called the National Weather Service about 1 minute after calling. The whole conversation lasted about a minute or so. So let's see. The first video was 45 seconds. The second video was 46 seconds. Minute and 4 seconds. That's already what? 1 minute and 50 seconds. That's almost 2 minutes, and then 2 more minutes. So I believe this whole thing between here and here, close to 10 minutes took place. Maybe not even. This is how quickly conditions deteriorated. It went from looking like a little shower was coming in to this.
I'm under the thing. Here it comes. Oh my God. We got like 40, 50 mile an hour winds right now. Holy crap. That's like 60, 70 mile an hour winds right now. Holy shit. Oh my God. Oh. Oh my God. Get in! Everybody just get in!
Even though I said the winds were 60, 70, they were probably 40 to 50, in my opinion. I definitely over-exaggerated the winds, in my basically geeking out. Let's go back to the radar again on radar scope. Okay, we have a tornado warning now. Just south of Coffeyville, Kansas, where the previous record hailstone took place, basically. Of course, before the Vivian, South Dakota before the Vivian, South Dakota. And it's not a supercell type. It's basically, and there was no confirmed tornado, thankfully. It was a brief spin-up type. And looking at the tornado warning, let's see what they wrote on the National Weather Service. Yeah, radar indicator rotation. So far, no confirmed tornado, thank God, and I hope it's going to stay that way. And there are some intense cells heading to Tulsa right now. Not as intense as earlier, thankfully. And remember that cell that looked like it might be heading toward Tulsa? Or I thought it was going to go to the south? Well, it's now going through Guthrie. And right now, Oklahoma City is getting hit by some pretty intense storms. The OKC area is getting hit by some pretty strong storms. They're severe warned mainly for some strong winds because they have the possibility of becoming severe. It's more for the possibility. The cell just basically formed. This thing ping pong ball sized hail. The cell does not look like it's producing ping pong ball sized hail. In fact, the reflectivities show that it's very weak. I think they're expecting it to basically blow up to that extent because the atmosphere is so unstable that even though it doesn't look like on radar it's producing that kind of hail, they believe that the instability is there. And it looks like there's a really strong hook on the northwest side of one of these cells, but oh crap. Oh my God. I think a tornado might form. I mean, there's a hook signature and there's rotation. Yeah, there's some pretty significant rotation just northwest of Guthrie. Yeah, we have a hook. I mean, that's why there is a 10% tornado threat. No, there is a hook, and there is basically rotation too. Oops, that's correlation coefficient. The rotation is not like extreme, but I'm sending it to Facebook right now. I'm sending 3 videos right now to Facebook. Thankfully, debris on correlation. The storm is not tornado warning though. It should be. If I were the National Weather Service, I would issue a tornado warning on that right now because the possibility is definitely there. Like it's definitely basically screaming that I want to produce a tornado. That's what that cell is basically saying right now. It's basically screaming, I'm about to produce a tornado. Thankfully, there's no debris. There's no confirmed tornado, and it's showing red. Showing red. So basically, okay. So now I'm gonna go to Facebook, to my Facebook group. I'm gonna go to. Alrighty. So let's go basically. Texas? Wait. We have a tornado warning? Hold on. No. Wharton, Texas? Come on, Guthrie. They're about to get RFD really bad. Nope, they already got RFD'd. Mm, come on, man. There's a funnel text. Come on, man. Henderson? Oh, Henderson. Got it. Henderson. Wharton, Texas. That's the only cell that's severe warning at the moment. There's something near Henderson. There's not a single tornado warning in Texas. Oh no, we got tornado warnings in Louisiana though. No, nothing showing anything like rotation though. All right, we got a single severe thunderstorm warning. Okay, they said Wharton, Texas. Where is Wharton? Where is it? Where's Wharton, Texas? The heck? Okay. I'm gonna go right now to Google Maps. Southeast of Houston. Okay, so it's southeast of Houston, right? There's nothing on radar there. There is nothing on radar. How the heck are you gonna have a funnel cloud with nothing on radar? No. I mean, there's a tiny little cell that has like the lowest reflectivity I've ever seen. Reflectivity is like what, 10 or 15, and it's not even showing any rotation. There's nothing. It's like a little shower cell. Wharton? So we got a tornado warning. Come on. Mhm. Radar indicator rotation. Yeah, that tornado report must be false. Yeah, because I do not see any rotation there in Wharton. All right. Yeah, it's basically squalling out. I don't think Tulsa's gonna get any hail unless you go just to the south and maybe like. Okay. Wharton, Wharton County, Texas. Mm, All right. So yeah, El Campo. So it's just northeast of El Campo. Listen. Okay. Working count is shaped like that. Only thing that I can find. Hmm, okay, Victoria. Okay, it's between Texas. El Campo. Wharton. Yeah. How the heck is there going to be a funnel cloud? How are you going to have a funnel cloud with nothing on radar? It's completely clear. Pretty sure it's a mistake. It's a mistaken report. Maybe it's like it was submitted just now, but it's probably from days ago when they had all that severe weather going through. I mean, there is a couple cells over Houston, over Baytown. It's producing a pretty intense gust front, apparently. Like there was like a little gust front that went through. Beach City got some rain. I mean, it's nothing severe. It's like it looks like a miniature dust front going through. It was basically some weak cells that went through the just southeast of Houston, and there's some pretty large hail according to Lake Charles radar. Yeah, that's some pretty large hail, I have to say. Now I'm looking on. Okay, now when I look on radar, I'm going to use correlation coefficient. There's no warnings in southeastern Louisiana. I'm not seeing any signs that there's going to be any large hail. Like I am seeing some signs that there could be some hail, but not large, not particularly large hail. Maybe some marble to pea-sized hail. So I'm going to go to tilt 3 now. Let's go to base reflectivity tilt 3. No, I'm not seeing any signs of hail there. There is a tornado warning in Louisiana, and yeah, that cell is definitely producing hail. There's no doubt. Emite City and Independence, Louisiana, they're getting hail. Like they are absolutely getting hail. There's no doubt that Emite City is getting some hail. I would say at least quarter sized. The rotation has actually completely went away. I'm not seeing any couplets right now that would produce a tornado. Emite City's probably seeing some marble to quarter sized hail. So, and yet on their hazard it lists for the tornado warning just tornado. Does not list hail. But I do think now hail is a primary threat. Hail and some strong winds. They should definitely issue a severe thunderstorm warning. I wouldn't say cancel the tornado warning, but issue a severe thunderstorm warning. You know, that's New Orleans now. The cells in New Orleans, there's jurisdiction right now. And, oh yeah, Tulsa's under a severe thunderstorm warning now. Oh no, it's heading toward Tulsa. It's like in the Tulsa area. It seems like Tulsa might actually get a little might get dry slotted, but there's new cells forming. So there's cells just to the southwest of Westport, just to the north of Sand Springs. There's a cell, and there's a really strong cell that is just south of Pawnee, Oklahoma. So like it's kind of aligned, but it's broken up. There's some broken cells coming through. So yeah, there are some discrete cells that are heading toward Tulsa. But right now the rotation is not there. see now. And Ivy, thank you for telling me about the volume. Alright, guys. So I'm going to be temporarily pausing the live stream. Just temporarily. I'm not ending it. Just that I'm going to be waiting for some of the real action to happen. I'm not going to be clicking this. I'm just basically pausing the live stream. Alright, guys. I'm back now. Just going to make sure it's still streaming. There, I just reset the stream again. I have too many windows open. Yeah, here's the video I was watching. There's the third part of the microburst again.
Get in! Come on, come on! Move in! I would not go out. we got hail!
I might have to raise the brightness on this. Hold on, go into settings. Yeah, because I always keep it to the bare minimum because I'm trying to conserve energy, you know, be environmentally friendly. So I'm like, I'm looking for brightness. Display. Yeah. Wow. There, actually, I can see the screen much better now.
We got hail! Oh shit, we got hail! Holy shit! Oh my god! Oh! Oh my god! Get in, get in, get in! Everybody just get in, get in! Get in! Come on, come on! Move in! I would not go out. Oh, we got hail! We got hail!
Oh. Ooh, actually, that was a pretty big bounce there.
Oh, we got hail! We got hail! Oh.
Normal, 0.25.
We got hail!
There's a chaos, so there's a couple there, a couple coming down.
Oh shit, we got hail! Oh, we got hail! We got hail! Oh shit, we got hail! We got hail! We got hail! We have hail! Right here! We have hail! We have hail! Oh God, we have hail! We have hail! Right here! We have hail! We have hail! Oh God, we have hail! Woo! Just melted in my hand. We have hail, about marble-sized hail, pea-sized hail coming down right now. Oh my God! Woo! I got marble-sized hail coming down, pea-sized hail with really strong winds. That was about 60-mile-an-hour hail coming down, pea-sized hail with really strong winds. That was about 60 hail with really strong winds. That was about 60-mile-an-hour winds just now that came in. And we have hail. Confirmed hail. Confirmed. We just had hail coming down.
This is crazy. Look at this, guys.
We do have small hail coming down with the heavy rain. Woo, that was close. Oh, the winds are dying back down now. Holy crap, that was intense. That was a really intense microburst just now. I'm gonna call the National Weather Service and just tell them what happened. Yeah, we had a hail too. Holy crap. Woo! That was intense. Woohoo! That was an intense little microburst that just came through. Small hail with it too. Oh.
Yep, that's Pico's Hank. I love his videos. Like, I love Jeff Petrowski's videos too. They're both amazing. Pico's and Jeff, they're like... So, here are my three favorite storm chasers. Reed Timmer. Like, I've been, like, a big fan of him since, like, all the way back. And, like, wow, ever since I heard of Reed, I've been, like, a huge fan of him. Pico's Hank, Reed Timmer, Roger Hill. Roger Hill. He's the guy who runs. You know the storm chasing company? It's called Silver Lining Tours. It's really amazing. You should check them out. Actually, they were in Joplin when it struck. Yeah, they were actually in Joplin. They, of course, Jeff being really, knew what was going on, was looking at the radar, got them out of harm's way, and they all knew that Joplin was going to get devastated. Jeff basically got them out of Dodge just in time, and yeah. So Reed Timmer, Pico's Hank, Roger Hill, and Jeff Petrosky, they're my favorite storm chasers. I mean, I have a long list of my favorite, but those are like my top 4 favorites. Of course, I really like Kelly Williamson, but he passed away a couple of years ago in a car wreck while chasing a tornado in Texas. It was really sad to hear. Unfortunately, I didn't know much about Tim Samaras. I mean, I knew about the documentaries. I just didn't know their names, but when I found out who they were, it was really devastating to know about. Storm chasing is a very, very serious, job. It's a job. It's not just because you're passionate about it. It's actually also saving people's lives. So I'm streaming right now. So we might be getting some severe weather here in the Northeast. Thursday afternoon in the Mid-Atlantic. So that's Thursday afternoon. There might be some severe storms, and even Friday we might be.
On April 29th, 2017, multiple. On April.
Oh my God! That probably was an F5. I mean, they were on the top of the transmission tower, and it wasn't even in the tornado. Like.
On April 29th.
Jeez. Guys, yeah, Ray bombs are getting worse. I mean, that video I sent you guys was kind of almost proof. I mean, let's see when this video was made. Back in a year earlier, so. In this video about the microburst, the one I made, there we go. 2019, June 30th. And of course, July 1st, I witnessed, it was actually the next day that I saw a hailstorm in Boston. The very next day, there was, I actually went to Boston deliberately to chase some hailstorms. Because I saw there was going to be cold air loft, there's going to be hail. Of course, I was not in a very good area that had contrast, so I unfortunately could not see the hail. If I had a dark contrast, like if I had an umbrella and I was by a parked car, especially a dark parked car, I could probably have shown you the hail. I should have probably been on a narrow street. But I unfortunately was in the right where the Boston Common was, and there were no parked cars, so I probably should have been a few blocks away. But I wanted to show you guys, the whole sky that was coming in. I don't even know if I even have that video still. Anyways, I think I deleted that Boston video. I might have uploaded them. Yeah, that was the day I was in Florida and basically saw that big hailstorm. Next day, I think there was some strong winds. Where's next back? Because I'm going to have to manually. There was some gusts. I think some gust fronts that went through. Nope. That was, I think, the next day. One of those days, there was some... I think that was that same day. Tornado. Yep. I was not in New York that day. April 28th, 2005, May 28th, 2005, I was actually in New York. I was actually still in Florida. So I missed that storm. Philadelphia, Pennsylvania. 69 miles per hour. Yeah, I was. New York. Anything from New York? Looks like there was a report right there in New York City, so they had to be New York. New Jersey, Camden, Burlington, Mercer, Ocean, Woodbridge. Ah, there we go. Jamaica, Queens, right in my area. Yep. Numerous trees down throughout Queens County. Yeah. Numerous trees down. Wow. Yeah, I actually missed it. I was in Florida. I think that what's his name might have got videos of it. Scott McPartland. He's a storm chaser who lives very close to my area. Yeah, I'm probably when I get more money, and basically, I'm probably gonna do storm chasing trips to the Midwest. And of course, I don't want to go storm chasing by myself. If I'm gonna go storm chasing, I definitely want to go in a team. That was probably a cold front coming through. I know there was storms over. I know they talked about a tornado in the Philadelphia area. There was a tornado in the Burlington, New Jersey area. A tornado in Burlington. Yeah. There was a hail. Let's see. Tornado. I'm gonna go forward to something. I think it was the last day I was in Florida. It was a come on May 31st. Yeah, I think actually that was the day, the 24th, I believe. No, the 25th, 26th, yeah. And so there was a wind report in Florida, Miami-Dade, Ventura. Let's see the hail report. Hail happened at 1914, yeah. Wind gust. Okay, so let's look. I'm gonna look at the radar. My friend who lived in Tulsa just reported some quarter-sized hail. And yes, we have some breaking news now from Campi Flegrei in Italy. There has been a pretty impressive earthquake swarm. Well, Campi Flegrei is a volcanic caldera. I have to say that it's been really impressive to see a swarm like that. One of the biggest swarms there in several years, perhaps even a decade at least. I can actually, this is one of the calling a friend of mine. I'm just gonna mute it for a moment. here's the thing. Once the caldera, once the hotspot moves over the Great Plains, you don't have any. The silica content is much, much lower, because the Great Plains just a few million years ago
The
tends.
hot spot never moves, bro.
Yes, but the thing
So
is,
the hot spot will always
yes,
be there.
yes, no, no, no. It's thing is, it's gonna, it's
Yeah.
no, no. What I mean is, once
like,
it's once.
like Hawaii, bro.
I know. But what I'm saying is, once it's gonna be where the Great Plains is, like where once the Great Plains moves over the hot spot, guess what's gonna happen? You're not gonna have explosive eruptions. It's only gonna be explosive once it's over the Rockies and the continental, the continental divide. Once it gets east of.
Actually, bro, we have. Yeah, actually, it'll still do a great time.
No, because the Great Plains does not have as much crust. Even though it's in the middle of the continent, you don't have as much crust to work with as you do over the Intermountain West. Once you get east, the amount of silica decreases substantially. So you're gonna have more effusive eruptions. You're gonna have more, like, not you're not gonna have one big shield volcano. No, you're gonna have volcanic fields, basically. Like what happened? Like
Andy, I don't think Yellowstone is ever gonna change.
it, it will change. It's going to change. Okay, do you know what the do you know the flood basalts? The flood basalts of Oregon and Colorado. You know when when the volcano was over like the valleys in Oregon, you didn't have super volcanic eruptions. You had massive flood basalts. But once it started moving over the, getting further. Okay. Okay.
There was never a not well. There's been many smaller eruptions, but when Yellowstone erupts and it's super volcanoes, like type eruptions, but they're big.
Okay. Do you know the Columbia River flood basalt? The Columbia River flood basalt, the volcanic province, that was part of the Yellowstone hotspot, the Columbia River basalt group, basically. Or
I don't remember that part.
okay,
No.
but yes, in the Columbia River, there is something called a flood basalt that basically erupted millions of years ago, and it was related to the Yellowstone volcanism.
Information, bro.
In the Northwest, you had Columbia River flood basalts, which erupted between 15.5 to 17.5 million years ago, and about 2 million years later is when basically the first volcanism of Yellowstone, basically the first caldera basically formed about 16 million years ago, which is right around the same time.
You need to look at where Yellowstone has erupted.
Yes.
And then do a study.
No, I'm
Then
following
come
it.
back.
But no, I'm trying to follow the continental drift. Okay, so the flood basalts was in Oregon and Washington, and then it drifted south. The volcanism drifted south, and then drifted northeast, as you know, because of continental drift. The flood basalts wasn't just because of the Yellowstone hotspot. There was also other volcanism because of faults. You had the northern Nevada rift dikes. You had the Chief Joseph dike swarm, Monument dike swarms. You had different, and you had a cratonic margin. So basically, formation. The formation formed about 10 to 15 million years ago. Sometime during a period of 10 to 15 million years, lava flow after lava flow poured out, eventually reaching a thickness of more than 1.8 kilometers. But the thing is, the transition to flood volcanism prior to 17.5 million years ago, the Western Cascade stratovolcanoes erupted with periodic regularity for over 20 million years, even as they do today. An abrupt transition to shield volcanic flooding took place in the mid-Miocene. The flows can be divided in four major categories: the Steens basalt, the Grande Ronde basalt, and the Wanapum basalt, and the Saddle Mountains basalt. Cause of volcanism, major hotspots have often been tracked back to flood basalt events. In this case, the Yellowstone hotspot. In this case, the Yellowstone hotspot initial flood basalt event took place. Yellowstone hotspot's initial flood basalt. Yellowstone was originally flood, but did not produce supervolcanoes, produced flood basalts. So basically, in this case, the Yellowstone hotspot's initial flood basalt event occurred near Steens Mountain. Can you lower the volume? When the
Huh? I'm just playing my game.
no, because I'm live streaming right now. When the Imnaha and Steens eruptions began, as the North American plate moved several centimeters per year westward. The eruptions progressed through the Snake River Plain across Idaho and Wyoming, consistent with the hotspot hypothesis. The lava flows are progressively younger as one proceeds east along this path. There is additional confirmation that Yellowstone is associated with a deep hotspot. Using tomographic images based on seismic waves, relatively narrow, deeply seated, actively convective plumes have been detected under Yellowstone and several other hotspots. These plumes are more focused than the upwelling observed with large-scale plate tectonic circulation.
And is this a trustworthy site you're getting this information from?
Yes, it's Wikipedia, but they do cite their sources. There is a lot of sources being cited. So, in fact, I'm gonna cite some of my. I'm gonna look. Yes. 9. Okay, Bishop 2003.
I gotta go.
All right.
I got stuff to
But
do.
before you go, just be careful about Campi Flegrei, because Campi Flegrei, while it's not a hotspot, it is subduction. Subduction volcanoes, in fact, produce some of the most explosive.
Never say it was a hot spot.
No. The most dangerous, the most, hold on. The most explosive supervolcanoes are not hotspot like Yellowstone, but subduction volcanoes like Toba, like Taupo. The most explosive supervolcanoes are always subduction. Subduction zone volcanoes are the most explosive because because while they don't trap, you there?
Yeah.
The most explosive volcanoes. While rhyolite is explosive in itself, rhyolite cools down. Rhyolite crystallizes very easily and is very hard to erupt. The thing is, Yellowstone
Using those gases, which makes it
more explosive. Yes, I'm aware.
eruptive.
Yes,
It's so explosive.
the most dangerous kinds of hotspot volcanoes is Yellowstone. Basically, a hotspot right over the continental crust, the mountainous part, because that's where you have the most silica. The more silica you have, the more sticky the magma is. So while the magma is basaltic below the continental crust, as it hits the continental crust, especially the thick part of it, where you have all the mountains, that's where you get the basalt to transition very quickly from basalt into rhyolite. I mean, you could get.
I mean, I showed you the picture of. There's no basaltic lava in Yellowstone.
No, there is. No, there is.
There is, but it's blocked by rhyolite.
No, let me explain. There actually is basaltic magma on the surface. No, there is basaltic magma at the surface in certain areas. But it's
That's way outside of Yellowstone.
no, in the caldera there is basaltic flows.
I showed you that picture before, bro.
Yes, but there were also rhyolitic flows too. Flows, not explosions. The last eruption at Yellowstone wasn't the Western Thumb Basin explosion, which was a VI7.
Let me show you again.
It was 70,000 years ago. So the last eruption at Yellowstone didn't take place 640,000 years ago. That was the last super eruption. But the last eruption actually took place less than 100,000 years ago. The last eruption at Yellowstone, in fact, the last eruption at Yellowstone took place 70,000 years ago. That was actually the Western Thumb Basin explosion. Last lava flow in Yellowstone. Last lava.
Yep. Told you.
The last lava. The most recent lava flow occurred about 70,000 years ago, while a violent eruption excavated the west thumb of Yellowstone, Lake Yellowstone, around 150,000 years ago. So 150,000 years ago was west thumb. 70,000 years ago.
Outside of the caldera.
No.
Inside the.
No,
inside
Jeremy, hold on. The 70,000 years ago eruption was rhyolite. Yes, it was rhyolite. 70,000 years ago, it was a rhyolitic lava flow. Right now, I'm looking at Campi Flegrei. Campi Flegrei.
Oh, you don't listen, bro.
What?
You don't listen.
I'm sorry.
I
No,
sent you the pictures.
Jeremy, I know.
Magnitude it looks like.
You're right. Hold on.
The salt is all blocked. The salt is outside of the caldera of Yellowstone.
Yeah.
All
Okay.
that rhyolite blocks off the salt.
Yeah. Jeremy, we're
Block rhyolite in Yellowstone.
right. Jeremy, we're about to have. Look. Right now, there is an earthquake swarm occurring at the Flegrei fields. And guess where? The quakes, they're in Puzzoli. Yeah, they're in Puzzoli, right in the caldera. Oh wow.
Well, actually, Naples.
No,
But yeah.
Puzzoli. The center of the swarm is in Puzzoli, where all the crazy stuff happens.
Bro,
Yeah.
I just sent a picture. It's like just north and west of Naples.
Yes, I know. I'm talking about the town of Puzzoli.
Technically inside the caldera.
Yes, the town of Puzzoli. That's where. Okay, you know the town where
I don't
the
know the town.
the docks. The town is called Puzzoli. There's a I watched videos about that town. After the swarm in 1980, guess what happened? The Roman docks are above water now. It's now considered a ruins. It was underwater, and now it's above water.
Yeah, I know that. I've seen that before.
And that's where the swarm is right now, in that same area. And they were like making this whole thing that they detected a bunch of fluids right below Campi Flegrei. And those fluids were magmatic. They also detected a switch from hydrothermal emissions to magmatic emissions just a few years ago. Jeremy, this volcano is very close to erupting. Very close.
We already know. Even Big Fur Yellow has said that.
Yeah.
She's extremely close.
Ben said that? I've been thinking that Campi Flegrei is going to erupt ever since Sean told me about it. When I did research on Campi Flegrei,
She's gonna erupt since I've ever started studying.
you knew it, so you...
Years ago.
Yeah, but right now, here's a list of volcanoes I'm most concerned about. Campi Flegrei, number 1. Long Valley, then Yellowstone. Yellowstone is the least on my concern right now.
Actually, I'm growing concerned on Tambora as it's becoming pretty active.
Yes, Tambora may be active, but it recently erupted. So the thing is, Tambora, before this eruption, has not erupted in thousands of years. So the thing is, and Tambora...
That's not really recent, bro.
No. Tambora had not erupted. The last eruption at Tambora was in 1967. The last big eruption was in 1816. But the last eruption in Tambora was in 1967, and it basically has lava flows now. It's done. It's done. Like Tambora is done. I mean, if it stops erupting,
You can never say that about any volcano.
I mean, look, Tambora is basically done. Unless you see,
And
unless
from what I'm seeing, bro,
Uh,
I've been seeing magnetic,
okay,
I've seen what is it? Low frequency events, which means magma is on the move
there's
again.
nothing. Okay, just because
And there's been storms.
you might have an eruption, but it's not going to be a massive eruption. You might have a VI1 or 2.
You cannot predict that. You can never predict how big it will be.
Okay,
It's just not, it's impossible.
you got to look at the deformation on the volcano. If you're going to have feet and feet of deformation, then it's going to have a massive eruption. But the thing is, you're right about one thing. You never know. But
So it's all more than just deformation. It's all about the type of magma it has as well too.
yes,
And
yes,
everything else.
and Tambora does not have rhyolite. It actually has
It doesn't
basalt.
have to have rhyolite to be explosive.
Not always. Tambora magmatite.
Let's look at the Icelandic volcanoes and
Okay, hold on. Mountain type. Trachybasaltic, trachyandesitic stratovolcano. It's not rhyolitic at all.
I never said it was.
Okay, formation. Tambora is located. Okay, let me look at formation. A high volcanic cone with a central vent formed before the 1815 eruption, which follows a stratovolcano shape. The diameter at the base is 60 kilometers, 37 miles. The volcano frequently erupted lava, which descended over steep slopes. Tambora has produced trachybasalt and trachyandesite rocks, which are rich in potassium. The volcano contains phenocrysts of apatite, biotite, sinoproxene, leucite, magnetite, olivine, and plagioclase, with the exact composition of the phenocrysts carrying different rock types.
Are the most explosive.
Which ones?
Bro, it's in this. Let me see.
Okay, I think maybe. Okay, hold on. Rubidium, strontium, and phosphorus pentoxide are especially rich in the lavas from Tambora, more than the comparable ones from Mount Rinjani. The lavas of Tambora are slightly enriched in zircon compared to those of Rinjani. The magma involved in the 1815 eruption originated in the mantle and was further modified by melts derived from subducted sediments. Fluids derived from the subducted crust and crystallization process in magma chambers. The SR86 SR ratios.
Is part of a convergent zone.
Yes, subduction zones. Yes, it's a subduction zone. The thing is, subduction zones are normally explosive.
One of the more explosive.
But why are subduction zone explosive?
Can be.
Because you have a lot of silica in there. It's andesite. Guess what? Mount St. Helens is andesite, but it's andesite, not basalt. Right now, Krakatoa is erupting like it's basalt. Before the flame collapse, it was having lava flows.
So don't downplay Tambora because remember the year without the server?
Yes,
Tambora was part of that.
yes, I know.
That's how explosive she can be.
All right, but here's another thing. You know Mount Rinjani, or Samalis, as we call it.
Yeah, which is a bit more west
Right, actually more east. But
or whatever.
the thing is,
Side of
it
Tambora.
it has frequent and regular eruptions. Yet in 1257 AD, 12 it had the most explosive eruption, more powerful than Tambora, by the way, even worse. It erupted more than Tambora, and it didn't cause a year.
Why is she part of the super volcanoes?
No, I'm talking about Samalas slash Rinjani. The 1257 eruption was worse than Tambora, and guess what? It killed thousands of people in London alone from famine. It globally killed hundreds of thousands of people globally. It killed a third of the population of London the next year, 1258. The 1816 eruption was nowhere as powerful and nowhere as deadly as the 1257 eruption of Tambora. Samalas. It triggered a global famine. Tambora also triggered some global effects.
Volcano is going to cause famine and destruction.
What?
I mean,
The 1257.
remember, if Yellowstone it erupts right now, 2/3 of the U.S. is uninhabitable, and it's right in the zone where we have all our farms.
Yes.
So, all those farms get
Yes,
destroyed.
but there's a big but.
Famine everywhere.
There's a big but. Guess what ash brings? Fertile. Very fertile.
Yeah, but it's going to be many, many years before anything would grow.
We're gonna lose. We're gonna lose 1 year of. We're gonna have a 1 year famine. Here's.
No, we're going to have volcanic winter for 10 years.
Yes,
bro.
but we have technology. We have technology. We have greenhouses. We have seed vaults. It's
But
look.
all that ash is heavy. Ash is heavy.
Ash is
and
heavy.
it will destroy buildings.
Ash is heavy, right? And the thing is, most of the ash is gonna fall within 200, 300 miles of the caldera, and then most of what's gonna fall east of the, most of what's gonna fall in the Rockies. I mean, not in the Rockies, in the Great
Bro,
Plains.
even all the way over here, a few centimeters is enough to collapse a building. There will be at least a few centimeters all the way over here in the east.
That's the worst case scenario. Say realistically, we get a VI7. Okay,
It's going to happen.
what's gonna happen if we have a crack at a Tambora-sized eruption at Yellowstone? More realistic, not a VI8.
That's still a VEI of 7, bro. It's
So, can you? Okay, right now no one's watching my stream. Damn it! Hold on. I'm posting. I'm posting it in the group.
I got stuff to do. My parents are wondering where I am.
Your parents, like, do they control you that much? Damn.
No, just I don't know. They want me to do something. So I probably should head off and do whatever I need to do. Alright, well, see ya, bro.
Hmm?
See ya. You're not gonna say goodbye.
No, wait, hold on, hold on. Don't leave yet. Can you wait for just one more minute?
Okay.
Okay, I'm gonna post something in the group. And the Storm Chaser group. Can you post it in the other group? The one you're in? The Sean's group?
I don't have, but
I'm posting it in the Amateur Storm Tracker group. Thanks, Jeremy.
where do you want it?
Hmm? In Sean's in the MeWe group, if you can post it, and the phone group, you know, the messenger group. Thank you so much, Jeremy. You know, I wish you all the best, and I'll talk to you later.
Alright, well, see
Thank you. Bye.
Yeah, bye.
Alrighty, so let's close this out. Actually, no tornado. Oh, darn! We have tornado warnings in Mansfield right now. Right now, we have a tornado warning in effect for Webster County in southwestern Missouri. Radar indicated rotation. No confirmed tornado, but locations impacted include Marshfield, Fordland, Diggins, Seymour, Niangua, and Northview. And I'm currently looking at velocities right now, and the area of highest rotation is just to the southwest of Marshfield, Missouri. Alrighty. Let's look at Campy Fligrai. Okay, that's not what I was thinking. Alright. Campy Fligrai. Yeah, that's what I've been looking for. Alright. So nothing today, nothing yesterday. Okay, that's good. Nothing on the 29th and 30th, but that's a pretty healthy swarm. Anything above magnitude 2. That's not good, guys. This is really, really bad. That's what I'm really concerned about. It's at 3.1. Let's go back to all of 2019. 2019. Show. Strongest was a 2.8. So we already had a 3.1. All 2018. Wow, cannot find a 3.1. Alrighty. And that's one. That's a lot of quakes for 2018, but nothing like big. So yeah. And let's see, the biggest quake was 1 kilometer. All 2017. Nothing there. All 2016. Okay, going back 4 years. Come on, magnitude 2. Nothing. Okay, just 1. Wow, that's the biggest quake in already 4+ years. All 2015. Alrighty, so beginning in all of 2015. All 2014. Alrighty. Guys, I'm looking at Campy Fligrai right now. Okay, magnitude 2+. Nothing. Wait a second. April 16th. Nope. All 2013. Guys, this is really impressive. It's already 7 years. Yep. All 2012. Yeah, this is the biggest quake in over 8 years. Yeah, 3.1. I need deformation charts right now. I need to look at deformation charts. guys, I'm changing gears right now. I'm not going to be talking about the severe weather though.
Thanks a lot, and good morning, everybody. And I wish to thank Carlo for giving me the opportunity to talk to you today. Crust is brought out
Crater Lake, USGS.
of the system very
That's Mazama right there.
fast. And if that's too fast, the system cannot re-equilibrate and it collapses down. There is a significant pressure decrease here so that all the system collapses down. When that happens, huge amounts of materials are erupted in a short time. And that gives origin to what we call the ignimbrite
I would definitely subscribe to European Geosciences Union. They're really good at what they do. I've watched a few of their videos.
eruption, ignimbritic eruptions, which again are the largest eruptions we know on Earth. And after that, the system is like this one. There is a large depression. Quite often in time, new eruptions occur from this place, so the depression can be partly or completely filled with new volcanic material, or it can host a lake, like in this other case here. Because volcanic ash are impermeable, they don't allow the water to go away, and so they produce an impermeable layer where the water can accumulate, producing a lake. So that's the way calderas form. And if we look at calderas, this is an example of Campi Flegrei. We can see here the ring-like structure of Campi Flegrei following the collapse of the structure, and many other craters and smaller calderas marking the activity occurred are impermeable. They don't allow the
Okay, guys, right now, I can't find anything greater than magnitude 3 going all the way back to 2012. I cannot. Not at the caldera. I can't find anything greater than Mag 3. Yeah, I cannot find anything greater than Mag 3 going even way back then. Even going all the way back, cannot find. I think when they were talking about the big swarm that caused the crazy uplift, the quakes were about the same. They were about 2 or 3 magnitude, but the uplift was like crazy. So yeah, basically, guys, it's important. Either is this or this. All right.
the water to go away, and so they produce an impermeable layer where the water can accumulate, producing a lake. So that's the way calderas form. And if we look at calderas, this is an example of Campi Flegrei. We can see here the ring-like structure of Campi Flegrei following the collapse of the structure, and many other craters and smaller calderas marking the activity occurred after the large caldera forming eruption. After the eruption that produced this depression here, we had many other eruptions which partly filled the caldera depression, while the other part here in Campi Flegrei is under the sea. And that's the case for Yellowstone, which is also another caldera, and the size of caldera can be very variable. At Campi Flegrei, we had around 12 kilometers in diameter, but we can go up to 50 or even more. The largest calderas we know are 70, 80 kilometers in diameter. So they are really huge, very big structure. And because they are so large, if you walk in a caldera, you might not have the impression that you are inside a volcano, but that's where you are. Those people there, they live in beautiful places. This is Campi Flegrei in Naples, but they should, and partly they are aware that they live inside the volcano, not close to the volcano, not on the volcano. They live inside the volcano. And that's the case for Yellowstone, which is a very nice, very beautiful environment, but still, if you walk here and there, you see the signs that this is actually a volcano. This is La Solfatara crater in Campi Flegrei, which is characterized by very large flows of gases coming from the magma, which is still sitting below Campi Flegrei, and produces energy which is as large as the impact with an asteroid. So the only fact is that the impact with an asteroid is a recurrence of 100,000 years, while caldera-forming eruptions are more frequent than that on Earth. This is just to give you an idea in terms of volumes erupted. These are the volumes of the product from the largest historical eruptions, okay? So the largest historical eruption is the Tambora eruption in Indonesia in 1815, 50 cubic kilometers of magma. And we can go down here, we have some of the most famous eruption here. This is the Vesuvius eruption in Italy in 79 DC, which killed about 5,000 people in Pompeii and gave us this beautiful archaeological remnants. This is the Krakatoa eruption in Indonesia in 1883, which someone says it inspired the Moon scream or Moon cry, because the volcanic ash, which was spread over the atmosphere and all around the globe, gave for many months a particularly red sky, and that inspired Munch for his celebrated picture. And this is the Tambora eruption, as I told you, in 1815, which produced the year without summer. In 1815, in Europe, there was no summer, there was no harvest, and for years the harvests were very poor. That caused heavy famine, deaths, mass migration. So that was really a large-scale event with global implications. These are all caldera-forming eruptions. The biggest eruptions we have in historic time, they were caldera-forming eruptions. So calderas are associated to the largest eruption we know on Earth. And if we have to depict the Campania Ignimbrite eruption on the same scale, we have to reduce it down because it will be like this. This is the Campania Ignimbrite eruption, as big as this, compared to what we have seen up to now, which is down here. Some of you may remind the Eyjafjallajökull eruption from Iceland in 2010, which caused the shutdown or air flight operations over Europe for days and caused billions of economic loss. And that eruption sits somewhere here. It's a vanishing point at the very beginning of this scale. So that's really nothing in terms of the scale of the eruptions. You can imagine what some like this might be. It will be something with an impact at the global scale with consequence which will be very large, not only in Italy, not only in Europe, but on the global scale. Okay, of course, Campi Flegrei, they also produce much smaller eruption. We have seen many craters inside the large depression of the caldera, and those eruptions can be much smaller. So if we go back here, this is Tambora is 50 cubic kilometers, this is 300 cubic kilometers. Most of the eruptions, well, all of the eruptions of the last 5,000 years of activity at Campi Flegrei are less than 1 cubic kilometer. But an eruption like this one, which is the largest eruption of the last 5,000 years at Campi Flegrei, the Agnano Montespino eruption, this one will be a complete disaster. That's still quite big. It's as big as the Mount St. Helens eruption. Apart from the fact that Mount St. Helens is in a remote area, there is nothing around that. While here we are in a city, in Naples, and we'll see that in a few moments. And this is the last eruption at Campi Flegrei, the Monte Nuovo eruption, which occurred in AD 1538. A very small eruption, as you can see, but still an eruption like this one would be a real problem in the area. And that's because 500,000 people live inside the volcano, live inside Campi Flegrei. You can see here from this picture, this is all Campi Flegrei, and Campi Flegrei are bigger than that. And the same city of Naples is sitting inside. A large part of the city, not all the city, is sitting inside Campi Flegrei. Okay, and this is Pozzuoli city, which is also very large. This is the Monte Nuovo eruption, the last eruption in 1538. You can see here it produced this new mountain. Monte Nuovo means new mountain, exactly that. And you can see how urbanized is the area around that. This is a picture showing the eruption in the 16th century. Still there were houses, towns, not the situation as today, of course. In fact, all the area here is heavily urbanized. There are about 3 million people exposed to volcanic hazard from 3 major active volcanoes, which are Campi Flegrei here, a caldera, Vesuvius, very famous Vesuvius volcano, and Ischia Island, which is also an active volcano, which erupted last time in medieval times. Okay, so it's 3 active, dangerous volcanoes and 3 million people living there, with a density of urbanization which in many places is comparable to that of Hong Kong. So it's really a huge problem. It's probably the highest risk, volcanic risk situation in the world. What are those kinds of hazards that are expected when you have a volcanic eruption? Well, a volcanic eruption is different from an earthquake and from a tornado because the kind of process, the process isolate.
To basically watch. No. Hey, no. YouTube, let's go Pozzuoli. Where's that uplift?
Stanford University.
Twigs.
and they were following a period of intense uplift that lasts more than 2 years. One main question that later on as an adult and as a geophysicist I tried to answer was, what's the nature and the properties of the rocks of Campifragre? Why do those rocks withstand such high strain before breaking? In the Campifragre caldera, there is a lead, which we call a cap rock. The cap rock is made of pozzolana, the volcanic ash from Campifragre. The microstructure of this rock is made of mineral fibers that are called tobemorite and ettringite. Tobemorite and ettringite are minerals that are found in man-made concrete, including Roman concrete. Actually, Romans engineered their concrete by using the pozzolana from Pozzuoli and mixing the pozzolana with lime. The Romans used the concrete to build the Pantheon, the Colosseum, but they also shipped the pozzolana throughout the Mediterranean, making possible the construction of several harbors. So once we found tobemorite and ettringite in the cap rock of the Campifragre, the question was, where does the lime come from? So at that point, we decided to analyze the rocks that are deeper in the caldera. And by analyzing those rocks, we discovered that those rocks contain spherules of graphite and a mineral that is called actinolite. Those two components were really the proof to demonstrate that the deep rocks of the Campifragre calderas decompose because of heat and the presence of mineral fluids that lead to the formation of compounds like methane, CO2.
My name is Aaron Rogers, and I graduated from Aviation Institute of Maintenance. Before I came to AIM, I was in the military. I worked on Blackhawks. I'd recommend someone go to AIM because it gives
In 79 AD, at the height of the Roman Empire, a great cataclysm struck the Italian peninsula. The mountain of Vesuvius, near present-day Naples, erupted, killing thousands and destroying the cities of Pompeii and Herculaneum. The only surviving account of the event comes from 2 letters by a Roman magistrate named Pliny the Younger to the historian Tacitus. These letters described exactly what happened in the days before and during the eruption. It was the first time in history a detailed account of such an eruption had been given. Explosive volcanic eruptions like Vesuvius are now known as Plinian eruptions.
The Romans did not realize that this was a volcano. They knew about volcanoes because Etna had erupted many times in Roman history, but they didn't know about Vesuvius. And in less than 24 hours, the city of Pompeii was buried under many meters of volcanic ash, and the city of Herculaneum was swept away by pyroclastic flows. The explosion was about the size of the eruption of Mount St. Helens in 1980. And Mount St. Helens, we calculate, had an energy release the equivalent of 24 megatons. Bear in mind, in the case of both Mount St. Helens and Vesuvius, that would be 24 megatons of energy released over a period of about 24 hours, as opposed to a nanosecond with a hydrogen bomb. When the eruption of Vesuvius began in AD 79, it created a cloud of volcanic ash that rose at least 50,000 feet into the atmosphere. The prevailing winds carried this to the southeast, and this dropped a large blanket of volcanic ash on the city of Pompeii over a period of about 18 hours. We know that about 1,000 people died in the city. As volcanic ash started to pile up, it placed a great deal of weight on the rooftops of the houses, and eventually the roofs collapsed, burying the people underneath. Pompeii was basically buried under more than 30 feet of volcanic ash. The city disappeared.
As bad as the ash cloud that destroyed Pompeii was, it was only the beginning. As the people in the nearby city of Herculaneum would soon find out.
As this volcanic ash cloud continued to erupt for hours, eventually it got to the point that the eruption could no longer propel the ash high into the atmosphere, and the cloud collapsed, producing pyroclastic flows. And these pyroclastic flows were mixtures of extremely hot gas and volcanic ash with temperatures on the order of 500 or 600 degrees Fahrenheit. Now, Herculaneum was better positioned initially because the prevailing winds carried the volcanic ash cloud away from Herculaneum. But Herculaneum was subsequently buried by these pyroclastic flows. So it's a very different story for them. In Herculaneum, the kind of preservation is different. Imagine concrete coming at you at temperatures of 500 to 600 degrees, incinerating everything, but subsequently preserving everything beautifully. In Pompeii, on the other hand, the people were encased in much more porous volcanic ash, and over the centuries, their corpses decayed, their bones were dissolved, and what we were left with were casts without any preservation of the people. In many respects, Herculaneum is better preserved, but it is much harder to excavate because of the difference between the styles of eruption that covered them.
It is estimated as many as 16,000 people died in the eruption of Mount Vesuvius in 79 AD. Part of the reason for such a tragically high number was the volcano itself.
Although the Romans did not know that Vesuvius was an active volcano, they were well acquainted with the benefits that active volcanoes provide. There was rich agriculture on the flanks of the volcano. In fact, Pompeii and the region were famous for the wine that was produced. There was also deposits that the Romans discovered that we now today called pozzolan. It's volcanic ash that when mixed with lime produces a concrete that will set underwater. This is one of the great discoveries of the Romans.
The abundance of fertile ground and other resources around Vesuvius has led to a dense and ever-increasing population around the volcano. And although Vesuvius has not repeated an eruption on the scale of devastation and loss of life as the 79 AD explosion, it is far from quiet.
Vesuvius remains quite active. Since AD 79, Vesuvius has erupted about 36 times, most recently in 1944.
With a large population living around Vesuvius, the Italian authorities are very concerned about the status of the volcano. However, there's much more volcanic activity in the area, and the threat extends far beyond just Vesuvius. The greatest concentration of people in the surrounding area is in the city of Naples, locally known as Napoli.
Napoli is probably one of the most important places in the world for studying active volcanism. More than 3 million people are threatened by possible eruptions from Mount Vesuvius and another volcanic center that few people outside of Italy know about, named Campi Flegrei. Campi Flegrei is Italy's supervolcano. You can think of it as Italy's Yellowstone. It's about 12 kilometers in diameter. That's much smaller than Yellowstone, but on the other hand, it's much more active and more threatening. We call these supervolcanoes calderas because what they are is big basins. The eruption is so big that no edifice is produced. The explosions erupt anywhere from 300 cubic kilometers to more than 1,000 cubic kilometers of material, and what you're left with is a big basin that we call a caldera. Campi Flegrei has produced several very large eruptions. One that we know about occurred 30,000 years ago, released 300 cubic kilometers of volcanic ash. About 15,000 years ago, a major eruption released between 30 and 50 cubic kilometers of volcanic ash that we call the Neapolitan tuff. That would be 30 to 50 times the eruption of Mount St. Helens. The Neapolitan tuff is widely distributed around the Bay of Naples. It forms yellow cliffs, and it's used in building stone a lot in the city of Napoli today. In Campi Flegrei, the ground moves dramatically. because magma is injected continuously at depth, causing the ground to rise, and then the ground will subside as the magma cools and shrinks. The earthquake activity is extreme. Probably a third of the population of Napoli lives actually inside the caldera itself. So the risk posed by an eruption from Campi Flegrei is to not just the city of Napoli, but really southern Italy as a whole.
The long occupation of the area around Vesuvius and Campi Flegrei has meant many generations of people have been living under threat. But it's also provided scientists with an unusual window into the study of its volcanic history.
Campi Flegrei is one of the first places where scientists were able to recognize and document significant uplift and subsidence of the Earth's crust. They could do this because in the Bay of Pozzuoli there are Roman columns that have been burrowed into by mollusks.
The Romans didn't build the temples in the ocean, they built them on dry land. So that dry land above sea level had to subside so that sea level came up, and then those mollusks could burrow in there. And then the land had to rise up again.
When the land would subside, the columns would drop down beneath sea level, mollusks would burrow into them, and then when magma intruded at depth and the surface of the Earth was pushed up again, these columns would be emergent and the mollusks would die.
This is all since the Romans. This is a couple of thousand years.
And so we can see those mollusks today and track over centuries the rise and fall of Pozzuoli Bay as a result of the restlessness of the Campi Flegrei caldera.
If you have these columns that were raised up and lowered down within the span of time of a couple of thousand years, imagine multiplying that by Earth time, and you can then imagine how mountains form, valleys form, oceans form.
December 2016? Okay, December 2016, right? December 2016? December 2016. Right, December 2016. Alrighty, December 2016 we said, right? And yet we just had our largest quake in the last, what, 8 years.
It was very enlightening.
The contributions of Campiflegrei have not been only to science. Over the centuries, other disciplines have been influenced by its unique National Institute of Geophysics and Volcanology.
And in a sense, feel the Earth rise as it rises.
Up progressively deeper and deeper rocks as you approach the Outbreak line. Now, of course, at the same time, erosion is occurring. You're building mountains, but you're also wearing them down through erosive processes. And so what we see now today cuts through the original crust that had been tilted and uplifted. What makes it even more special is at the very top of this tilted section of rocks, we have a caldera, a supervolcano, something the equivalent or similar to a Campiflegrei or a Yellowstone, but much older. This caldera is about 285 million years in age, and we know that that's when it formed because we can date the rocks using the decay of uranium to produce lead. Everybody is familiar that uranium is radioactive, and when it does decay, it produces a certain specific isotope of lead. Looking at the ratios of these isotopes, we can calculate the age of the minerals that host them. So we know that this system was active at about 285 million years ago. And beneath it is a magmatic system exposed by this tilting as well. It's the only place in the world where such exposures exist. What's particularly interesting about this is what you can see in the field when you look at the rocks. It's what the geophysicists imagine exists at depth beneath Yellowstone, beneath Campiflegrei, when they look at their seismic data. They see a magma chamber perched at a depth of about 4 or 5 kilometers that's feeding the eruption. And then beneath that is a much deeper, larger volume of magmatic rocks that's providing the heat that drives the whole system. This is at a depth of more than 20 kilometers. And in Valsasia, we see this whole section beautifully displayed, and we can look at the relationship of these rocks and gain a better understanding of how the
Supervolcano to depths previously thought impossible. The Lardarello complex is allowing geophysics
Experience Boost raised my credit score by 12 points instantly, which is insane.
So I raised my
Moto in Campania, più scosse in sequenza attraversando la e sono stati grei nella Cimoti sono stati chiaramente avvertiti in Campania. Decimo provenienti Nura e Bagnoli, scosse in sequenza il terremoto in provincia di Napoli è stato registrato dal terra, gradi di magnitudo. Il fatto che sia
regarding world trending news, subscribe our channel, press the bell icon and like and share with your family.
A few minutes ago in Spain.
Si ripete a Pozzuoli un'altra giornata consecutiva che spacca in due il sorriso dei tanti cittadini pugiolani. Il Dipartimento Epidemiologico dell'ASL Napoli 2 Nord ha comunicato che dagli ultimi 45 tamponi analizzati non vi sono risultati nuovi casi positivi al virus. Il Dipartimento Epidemiologico i cittadini pugiolani. Il Dipartimento Epidemiologico dell'ASL Napoli 2 Nord ha comunicato che dagli ultimi 45 tamponi analizzati non vi sono risultati nuovi casi positivi al virus. Si registra però un altro decesso che porterebbe a 12 le vittime da Covid-19. La donna purtroppo deceduta rientra nel link epidemiologico del Santa Maria delle Grazie. Alla famiglia va tutta la nostra vicinanza e il nostro sostegno per qualsiasi cosa e le condoglianze dell'intera città. Queste le parole del primo cittadino Vincenzo Figliolia. Dall'inizio dell'epidemia ad oggi sono 685 test Covid effettuati nella cittadina capofila dei Campi Flegrei. Non abbiamo ancora vinto la guerra, ma cominciamo ad intravedere la luce, aggiunge Figliolia, e vorremmo arrivare alla fine di intravedere la luce, aggiunge Figliolia, e vorremmo arrivare non abbiamo ancora vinto la guerra, ma cominciamo ad intravedere la luce, aggiunge Figliolia, e vorremmo arrivare alla fine dei Campi Flegrei, nella cittadina capofila dei Campi Flegrei. Non abbiamo
Buongiorno a tutti, mi conoscete, sono Alfonso Coppolo della CISL di Quarto e faccio un appello al comune.
La scorsa notte la caldera flegrea è stata investita da uno sciame sismico di magnitudo compreso tra 0.0 e 3.1. L'ultima scossa è stata avvertita in tutta l'area flegrea. In alcune zone la gente si è riversata in strada. Non si rilevano danni a persone o a cose. Dall'osservatorio vesuviano arrivano le rassicurazioni. I sismologi non hanno rilevato anomalie rispetto all'andamento attuale della crisi bradisismica in atto.
Questa notte nei Campi Flegrei, nella conca di Agnano, in località Pisciarelli, che è il bordo orientale della Solfatara, bordo esterno orientale della Solfatara, sono stati localizzati diversi terremoti. Quello che viene definito uno sciame sismico. Si tratta di fratturazione delle rocce sottostanti e liberano energia con eventi sismici in questo quello che viene definito uno sciame sismico. Si tratta di fratturazione delle rocce sottostanti e liberano energia con eventi sismici in questo.
Alright guys, so right now let's look at Campi Flegrei.
In questo caso anche abbastanza molto intensi. Alle 4:41 e alle 4:59 sono stati avvertiti due grossi terremoti per i Campi Flegrei, ovviamente non è un
This is from 1970, by the way. basically when it all started happening. See? That's because the land was rising. Yeah, that's not... By small earthquake, it really means really fast uplift. And the evacuation didn't happen in 70. It happened in 1980. Oh yeah, look at that water there. It's coming up. That place is no longer water. See, it's all above water now. That's why people were filming that, because most of that was actually underwater. This is back in 1970. You know, that's not what I want to watch. Yeah. See, back then it was all water.
What I'm going to do in this class is use the lessons of history to apply to your daily life.
It was all underwater, and you showed a big area that was underwater. It was only a small amount that was subsidence, the land rose again. Around 1500 to the last eruption in 1538, the land again subsided gradually. Then between 1969 and 1973, the land rose by about 1.7 meters. Over the following decade, there was a little subsidence. Then between 1984 and 1994, there was uplift of almost 2 meters. Concerns about risk of earthquake damage and possible eruption led to temporary evacuation of the city of Pozzuoli. Temporary evacuation of the city of Pozzuoli. Let's see. let's see, modern investigations. This is what I was looking for. Finally. Whoa. Now it is. Okay, I don't know what that number. Alrighty, so this is basically. Oh wow. That's a pretty big earthquake. Okay, is that a Jewish person? 'Cause I'm Jewish. Let me see. Yeah, I'm not sure. Possibly. I want to see the magnitude of the quake. How big the. Wow, look at that. Subsidence by several meters. Look at that. 1538 eruption and then back to subsidence. Hold on. Guys, there isn't any tornado. now looking at the radar. We have a couple tornado warnings. We have a tornado warning for. We have a tornado warning for north central Pushmathia County. Pushmathia County in Oklahoma. Pushmathia County. Radar indicated rotation. Locations in or near the path include Clayton Park, Stanley, Sardis, Clayton Lake State. Oh wait, Clayton Lake State Park, Stanley, Sardis, and Tuscahoma, because that was a little weird, because it sounded like I was just reading park. Include Clayton Lake State Park, Stanley, Sardis, and Tuscahoma. Or if I'm going to go in order, let's see. Yeah. I'm going to go in order then. Clayton Lake State Park, Stanley, Tuscahoma, and Sardis. Those are areas impacted by this tornadic thunderstorm, basically. As I take care of now, I'm looking right now on radar, and there is rotation just to the northwest of Clayton. There's absolutely rotation with this. Do we have a let me see if we have a confirmed tornado. I'm going to look on correlation coefficient right now. And it's really hard to tell because it is pretty far away from the radar site. Nearest radar site is actually Fort Smith, Arkansas. So it's pretty far. It's KSRX. So it's, and the second nearest station is, yeah, there's no radar station anywhere near there. There definitely needs to be a radar station. I believe coverage areas poor in certain areas of Oklahoma. I believe northeast Texas and southeastern Oklahoma absolutely need their own radar site, and especially towns like Durant, Boswell, Paris, Texas. They need their own radar site. They absolutely need their own radar site. They have very bad coverage there. That's why you have mobile Dopplers. But what is it going to cost to construct a new radar site? Maybe 10 or 20, maybe at tops, maybe 30 million? And how many lives is it going to save? Maybe not even that much. There's certain areas of Kansas that don't have radar sites. Then again, just because you don't have major population centers, you still need a radar site there. Areas that need radar sites are places like Coffeyville, Shannon, Eureka. Like, they need a radar site pretty bad. Like, there's a lot of areas where radar coverage is really poor. And now, wow, Kansas City, St. Louis looks like it was hit by a tornado. Because no, it was not a tornado there. Radar indicated rotation. But yeah, it looks like St. Louis was hit by a derecho or some sort of, very strong wind event. Nope, it was brief rotation. Thankfully, oh no, might have a. What's only radar indicated rotation? Now we have a tornado tornado warning for Clarksville, Arkansas. Tornado and quarter-sized hail. Locations impacted include Clarksville, Lamar, Knoxville, Woodland, Lake Dardanville, Oak Grove in Johnston County. Oak Grove in Johnson County, Hunt, Harmony, Ozone, Hillcrest, and Union City. This includes Interstate 40 between mile markers 44 and 66. Take cover now. Move to a basement or interior room on the lowest floor of a sturdy building. Avoid windows. If you're outdoors in a mobile home or in a vehicle, move to the closest substantial shelter and protect yourself from flying debris. Tornadoes are extremely difficult to see and confirm at night. Do not wait to see or hear the tornado. Take cover now. Yes, we cannot stress this enough. Nighttime tornadoes are the most dangerous. And right now, it seems like the tornado, if there is going to be one, will be very close. Come on, lower. Come on. If there is going to be a tornado, it's going to be very, very close to... Let's see where it is right now. It's approaching Clarkville. I mean, it doesn't look like a tornado, but there is definitely some rotation there. It's broad. There's some broad rotation there right now. Earthquake looks like it was pretty significant. I mean, people are crying, there's like some damage. I mean, that was probably a magnitude 3 to magnitude 4. I don't think this was a 2 or 3. This was probably at least a 3. At least. I mean, I would probably say it was between mag 3 and mag 4. I'm trying to see how big it was. I do like the Associated Press. Well, I'm gonna temporarily stop this live stream, not ending it. I'm gonna pause it because I'm trying to find out some more stuff, basically. So you know I could watch this. Pico's hanging out.
On April 29, 2017, multiple tornadoes would touch down east of Dallas, Texas, 2 of them deadly.
I've got a woman. I'm taking her to the hospital. All right, be careful.
A stationary boundary positioned over the town of Canton would serve as a track for tornadoes to train down, one after another.
Man, it's heading right for town.
For the folks in Canton, the nightmare was never ending.
Oh my God, those people gotta get out of here. Those people gotta get out of here. They're gonna die.
For a veteran storm chaser, the third and largest tornado of this family was the scariest tornado I've ever witnessed.
Oh man, this thing is moving fast.
Tracking highly visible tornadoes over open land is more mesmerizing than scary. Continuous clear view of the rain-free storm base helps you predict storm motion as you gawk with confidence. The first tornado I witnessed was small and rain-wrapped, causing only EF0 damage to trees and barns east of Canton. After this weak tornado dissipated, a large killer was developing upstream and racing toward town.
We're riding its path right here. Gonna jump over these trees any second now.
High precipitation storm modes with low cloud bases tracking swiftly over thick forest are extremely risky conditions to chase in. If you could see through this wall of trees, you might see the low contrast silhouette of the deadly tornado 60 seconds before crashing into you. And at 30 seconds away, In these conditions, at 15 seconds before impact, you still might be completely unaware of your fate.
There it is. Holy. Big day. Coming right this way. Those people gotta get out of here. Oh my God, those people gotta get out of here. They're gonna die. Oh man, those people better get out of there.
The shrouded tornado badly damaging houses right behind me will strengthen to one of the most powerful tornadoes of 2017. It will level a 2-story brick home and sweep much of the foundation slab clean of debris. Many people will be injured and 2 will lose their lives before this EF4 finally dies.
That's it right there. That's it.
Meanwhile, another powerful killer tornado is developing to the south.
Just got a glimpse of it. All right, there it is. Let's go get it.
While positioning for a closer view, the trees obscure clues that this intensifying tornado is moving much faster than I calculated.
Okay, we're right in its path. Is it dying? I can't tell. I hope there's no people in those trailers. Inside the bear's cage, and it is. Oh, and we're too close. Gotta run. Gotta run, gotta run, gotta run, gotta run. It's coming. It's coming. Come on. It's coming. It's coming. It's coming fast. Oh, man, I f***ed up. It's coming fast. Oh, Jesus. This thing is moving fast. Okay, I got a clear road. Dude, you guys better run. Okay. Scared the hell out of me. Oh, it's coming fast. Gotta go. Okay, I think I can watch it safely here. A little too close. Oh man. Once it passes, let's listen to it. It's heading right for town.
At this moment, a wedding venue is being overrun with 20 people crammed in an interior bathroom. After the mile-wide tornado passes, it will be the only room still standing. Everyone will survive.
And there it is.
tornado is now destroying a Dodge dealership, tossing cars up to a half a mile. A woman was killed as her car was thrown from the interstate into a field. Another man will lose his life, as well as many farm animals.
It looks like it's over a lot of trees. I mean, there's houses everywhere out here, but it missed the main part of town. We're gonna have to go check on these people.
After the tornado has passed, hazards are scattered everywhere. Twisted metal, spears of splintered wood and nails, glass and rebar.
Wires everywhere. I can't.
Power lines down to cross lawns, roads, and wreckage can easily kill you, even if you are standing several feet away, especially in wet conditions. Your throat and nostrils often burn from broken lines pouring gas into the air. The worst thing you can do while trying to assist tornado victims is become a casualty yourself.
I just saw another tornado right there. There's a tornado following it right in there. See it? There's another one. You guys can keep chasing if you want. Alright. I guess I could go check out in that field for people. Oh, damn it, there's cars. Be right back.
At this moment, I'm running out to check this vehicle for possible victims. It never occurred to me to check this leveled pile of rubble for survivors. On the way, a woman had crawled out of that mangled rubble. She was badly bleeding from her head and watching over her husband, who was lying on the concrete with a broken neck.
I've got a woman. I'm taking her to the hospital. All right, be careful.
The woman in my car had lost just about every material possession she had.
How you doing back there? I'm good. She said she's good.
Despite the injuries to her and her husband, she hadn't lost her faith or her sense of humor.
And your name again?
Hank. I forgot your name.
Good. I don't feel so bad.
The gravity of the situation was offset with joking and gratitude, and I tell you, I might have met a stronger woman, but I can't remember when.
We're tested, then we moan, and then we have a testimony.
Before walking together into the ER, with blood running down her face, she paused to say a prayer for me.
Father God, I just thank you for Hank. I ask you to protect him in his storm chasing, and that you bless him and his wife for everything he's done for us.
Amen.
The next morning when I was cleaning my car, I found a gun she left in the back seat. Welcome to Texas, y'all.
Shortly after all this craziness, I had the honor of meeting up with Vicky and her family for dinner and more joking and storytelling. Vicky and her husband Jim are recovering and slowly rebuilding, but as you can imagine, they've accumulated a ton of bills. If you'd like to help them out, there's a fund drive helping to rebuild their community of Fruitvale, a little town just outside of Canton. If you donate $20 or more, you could win a free Mustang convertible or a Harley Davidson. I'll leave that link in the description below. If you're struggling to pay bills yourself, even sharing this info can help them out. Till next time, Vicky, happy trails.
You know, nobody really likes YouTube ads. I can't remember a time being like, yeah, an ad. So
Oh, it's spinning. Where is it? Okay, we're kind of inside of it. We're rolling, right? Oh, it's close. Oh, it's close.
quality writing.
You know, nobody really likes YouTube ads. I can't remember a time being like, yeah, an ad. So this...
Oh, it's spinning. Where is it? Okay, we're kind of inside of it. We're rolling, right? Oh, it's close. Oh, it's close.
The strongest part, I the video. So you see how it's hazy over here? That's actually you see all this haze? That's actually precip. And look, that's tree limbs flying. Yeah. Let me show you what I'm talking about. So Mississippi tornado. Inevitable. Invisible.
Hi.
And you look fantastic.
Thank you. I finally hit rock bottom when I realized for my 34th birthday, I didn't want any.
On Easter Sunday, April 12, 2020, an extremely dangerous, long-tracking, deadly tornado was underway in Mississippi. Doppler radar displayed an impressive supercell with a well-defined hook echo, powerful velocity couplet, and lofted debris. But views from close proximity locations told a different story. Vague walls of gray, towering pine trees, and wrapping rain completely obscured this hell on earth.
It's right next to me.
Seemingly unaware, civilians continued driving toward the tornado.
Where it crossed. It was right next to that first tornado. You could hear it. It was so close, but it was wrapped in rain. Once the tornado cleared the road, all the trees had blocked passage, so I turned around heading back for tornado number 2. But of course this one, the first one, left a swath of damage, and found a sheriff redirecting traffic around, and I was telling him where the tornado was, the second one was going. And
turn around and go back. There's another tornado.
I can track it for you from right here.
What are you, a weather
Yes,
guy?
sir.
Where's it at?
Right now it's north of Sosa, right through here.
Right here where we're at?
Yes, and I'll track it with you and tell you where it is.
Tell you what, just pull over a little bit and block that entrance right there.
Copy that. And these two women walked up and they said, have you seen if anybody's in this house up here? And we looked up and we didn't see a house. Officer said, there's a house up there? They said, yes. So we all ran over this hill, through the bushes, climbed over the fallen trees, and there was a pile of rubble on the ground. Hello? The man's name was James, and so we were yelling James into all the crevices, and the fireman got on his stomach and started slithering on his belly into the house, yelling James. The sheriff was on the roof yelling James. The women were just standing there in horror, and I didn't know what to do, so I told him that he'll be fine, that, you know, there's plenty of room to live inside the house, that it wasn't blown away at least. I saw this guy walking down the road. He had blood on his head, blood on his arm, mud all over him. And I said, are you James? He said, yes. I said, is that your house? And he said, yes. It took me 20 minutes to crawl out of the damn thing.
I've lost 13 pounds so far, and I'm only on week 5. I've been doing...
I remember tracking that tornado, telling people that so-so is going to be hit. I remember I was going to... The Weather Channel was tracking it, you know. They were doing a great job. Thank God for dual pol. Thank God. But... Guys, let's see if anything's changed. So let's see, we had a 2.0, okay, on the 26th. So the last big quake happened on, I think we had it 27th? Look at that, the 26th is when we had the big quake, see, 26th. And we had some quakes on the 27th, 28th. We had some really small quakes though. Small magnitude 1 on, so this is where you had the swarm. 24th you had a quake as well. Let's see how many 2s there were. There was 1, 2, 3. Okay, there was 1, 2, 3, 4. 4 quakes above magnitude 2, and above magnitude 1. Let's see, 1, 2, 3. 1, 2, 3. 1, 2. And above magnitude. Let's see total quakes. Above magnitude 1, there's 1, 2, 3, 4. So there's a lot of quakes, and the rest are probably under magnitude 1. Let's go to magnitude 2 plus. So 4 quakes, including the 3.1. 1, 2, 1, 2, 1, 2, 3, 4. Yeah. 29 kilometers from epicenter. Light shaking. Definitely woke the house. So somebody, Doromento knew this was somebody wrote. Unsure what to do at that point. Interesting and a bit unnerving. Can't imagine how 1 or 2, 3 orders higher would be. 4 to 4.4 kilometers west from epicenter. So that's pretty far. Light shaking. Woke up from sleep because my bed was shaking. Realized that small decorative item on shelf also fell. Those are reports, basically. No, these are reports. These are actually people's reports. Woke up from sleep. Okay. Second earthquake I felt this night. I thought a few minutes before this one. This one's like the strong one. I already felt it. Without reports. furthest one was, I believe, this one. So, it's shaking. Decorated item on shuffles effect. Well, probably 3.1, so it affected a small area. This is definitely a volcanic quake. That's Monte Novo, I believe. That's Monte Novo. Wait, no, Monte Novo is actually here. That's Monte Novo. Monte Novo. Yeah, Monte Novo right there. They're 35 meters high. The most dangerous part of the caldera is actually here, not here. This is the more dangerous part of the caldera. This is basically where all the uplift is centered, where all the swarms are occurring. So yes. In fact, you could even look and see where all the swarms are occurring. You want to know where a Pozzuoli is? Pozzuoli is right here. This is Monte Novo. That's Monte Novo. See? I'll show you where that is. Google.com/maps, and I'm going to show you where that swarm occurred. Pozzuoli. There we go. There's Pozzuoli. Ruins. Ruins. And of course everything's closed because of the... That's where it happened. And where did the earthquake happen? So the earthquake swarm was centered right about here. This is where the swarm was captured. INGV. INGV. So, oh wow. There's definitely some tremors going on. Tremors. There's some harmonic tremors going on. That is not good, guys. It's not good. Oops. Save image as. Wait, is this Capiflagra or is this Vesuvius? Absortio Vesuviano. Sorry. Which volcano is this? No, that's Pozzuoli. Okay, save image as. I don't know if it's going to be an imminent eruption. Yep. Yeah, they are idiots. Those people are idiots. Idiots. Alright guys, I think this is enough for today. I don't know how strong that quake was in 1970, but it was definitely stronger than magnitude 3, say. The record of earthquakes on Naples Bay is probably complete. Explosive caldera. According to this record, intense earthquake swarms beneath Campo Flegrei, an explosive caldera located along the north coast of Naples Bay, have occurred only twice. One, before the only historical eruption in Campo Flegrei in 1538, and two, from mid-1983 to December 1984. Earthquake activity during the earlier period, which began at least a few years, and possibly as many as 30 years before the 1538 eruption, damaged many buildings in the city of Pozzuoli, located near the center of Campo Flegrei. Minor seismic activity, which consisted of only a few felt earthquakes, occurred from 1970 to 1971. The second period of intense earthquake swarms lasted from mid-1983 to 1984, again damaging many buildings in Pozzuoli. Two periods of uplift along the shoreline within Campo Flegrei have also been noted since the mid-15th century, during the few decades before the 1538 eruption. And as two distinct episodes since 1968. Uplift of a few meters probably occurred a few decades before the 1538 eruption. The uplift of as much as 3 meters has occurred in Pozzuoli since 1968. These similarities strongly suggest that for the first time in 440 years, the same process that caused intense local earthquake swarms and uplift in the early 1500s and led to an eruption in 1538 has occurred again beneath Campo Flegrei. Although no major seismicity or uplift has occurred since December 1984, yeah, this must be pretty old. 1984. When is this from? August 1981. Yeah, because there's a lot of uplift right now. There's been like very rapid uplift. Eruption 1538 has occurred again. Although no major seismicity. Because of that large amount of extensional strain accumulated during the past 2 decades, if a third episode of seismicity and rapid uplift occurs, it may lead to an eruption within several months and after the resumption of activity. And that's from 1991. Wow, this is not recent at all. This is what they're saying here. I'm trying. That's the one I was trying to talk about. The Financial Times. Let me look at their political leaning though. Financial Times. Political bias, probably center right. I'm gonna guess. Financial Times media bias. They are center. Low. highest. Ooh. Factual reporting high. Yeah. And so, let's see what the Financial Times has to say. Oops. That was the wrong one. Just updated it like the other day. So what the Financial Times has to say, basically. This is basically Naples, and Campo Flegrei is right in that area. That's Ischia. That's Ischia right there. And that's Monte Novo. No, that's Solfataro or Monte Novo. I'm not sure. I think that's not Vesuvius. That's Ischia. That's Ischia. And that is, I believe that's Pozzuoli right there. And no, this is Naples and Pozzuoli. There's Campo Flegrei right there. Pozzuoli, I believe, is right over here. Monte Novo, I believe that's so yes. Volcanologists have recently assumed that the stress built up during the three main periods of unrest, the 1950s, the 1970s, and 1980s, dissipated during the quieter intervals between them. New studies based on geological observations Campo Flegrei and similar volcanoes also in the world and published in Nature Communications comes to the opposite conclusion. We consider that the crust in the caldera has a kind of memory and stress accumulates over the decades, says Stefano Tarlino of the Vesuvius Observatory. Any substantial new uplift could split the ground beyond its breaking point and trigger an eruption. Italy is currently on edge following destructive earthquakes in Umbria, Marche, and Lazio within the last 12 months. Italian scientists undertaking seismic studies face political as well as scientific controversy as they try to balance the risk of providing warnings that may turn out to be false alarms against the risk of complacency. The scientific world was outraged by the prosecution of several experts after the 2009 La Aquila earthquake for allegedly providing unjustified reassurance that no big quake was likely. In Campo Flegrei, local feelings were not helped by forced evacuations of as many as 40,000 people from Pozzuoli, a port near the center of the caldera. During periods of geological unrest in the 1970s and 1980s, when a series of earthquake or eruption was expected but did not occur. We have a problem with public perception because people have been through two emergencies and no eruption, said Professor Kilburn. The Vesuvius Observatory researchers are keen to drill a 3.5-kilometer borehole into the Campo Flegrei caldera to provide scientific observations of the volcano's conditions that would lead to better predictions of future activity. They already obtained data from a half-kilometer pilot hole, but the main $8 million Campo Flegrei deep drilling project has now been stalled by lack of funds and by local opponents who fear that it could trigger an eruption by providing a route for magma to escape. Giuseppe Di Natale, a leader of the project, categorically denies this. We know from our studies here and from experience of deep drilling in volcanic locations in Iceland and elsewhere, there is no risk of causing an eruption, he said. We need the observations not only for scientific research, but also to improve the civil protection of people living there. The researchers cannot predict when Campiflagrae will erupt again or the destructive power of the next eruption, but they say local authorities and people living in the Naples region for whom Vesuvius is a more visible threat should take seriously the risk from smoldering caldera, from the smoldering caldera of Campiflagrae. There we go, and let's see, this is May 17th, and this is October, basically. This is Discover magazine. This is Discover. Like, this is basically a scientific magazine. And this is where the earthquakes are centered. Oh no, that's Vesuvius here. Oh yeah. In 2012, the land within the caldera. Okay, let's go to volcano discovery. This very nope. No. This is the one I was looking for. So let's look. This is 2012. This is where they basically were concerned about the eruption happening because of this period of uplift unrest here. They say, oh, the uplift began and look what happened. Has the uplift slowed down? Nope. It's been increasing very, very quickly. Like, let's see. Since 2012, just since 2013. Let's go from 2011. Well, let's go from about here, because this is where it basically had a little period of subsidence right here. And then just uplift from then on out. This is basically when magma began intruding. This is all magmatic now. This is not hydrothermal like it used to be. This is all magmatic, by the way. This is kind of, this volcano is behaving a lot like the Tal caldera. This is behaving very similar to Tal. Let's go from 2014. It uplifted. This is basically the lower end of the spectrum. This is the low end. This is not different models. This is, I believe, like, this is basically could be variations. So it's anywhere from 320 as high as 600. Let's see. They're saying here. GPS at various stations. Oh no. This is GPS? Then let's see. Let's see. This is RITE. This is probably these this is just different stations. This area is just having less uplift. This area is having more uplift. And a ground inflation. So this is basically up. Let's see. Let's use this one here. From no uplift, so basically a period of stability here. Beep, nothing, and then shut up from there. So from 160, so subtract 600 from 160, basically. And only 5 years, 5.5 years. Calculator. Oops, wrong one. It show you the amount of centimeters, and this is, I'm not even going to go from 2011, I'm going to go from 2014. And
I can learn to understand you much better if I can get familiar.
600, let's go 160, let's go from here, from 560, minus 160. That's going to be 400. So 400 millimeters of uplift in only 5.5 years. Let's go to millimeters to inches. It was 500 millimeters. 300. That's over a foot. Darn it! Only 5.5 years. That's over a foot of uplift. Jeez, that's impressive. Even Yellowstone and Long Valley don't have that kind of uplift. Jeez, that's scary. In fact, you had a 3.1, the strongest, even going back to this period. Oh my God, it's not good at all. I mean, I don't know if you can have a super eruption. I'm hoping if there's going to be any eruption, it's going to be like what happened in 1538. So there are numerous small eruptions that happen every couple hundred years at Camp Flegrei. In the last 5,000 years, you had an eruption as small as Monte Nova to slightly smaller eruptions to as large as Mount St. Helens. There was a 0.9 kilometer eruption. Even if the big feared eruption doesn't happen, even if you get a Mount St. Helens eruption, that's basically Vesuvius size. If you get a Vesuvius size eruption at Camp Flegrei, tens to hundreds of thousands of people could be killed, especially if it erupts with no warning. Basically, like say kind of erupts like the way Powell did, just a sudden eruption with no warning. And the volcano would go from level 2 to basically the highest level warning, and people will be scrambling to get out. You're going to have traffic jams, and many people might die trying to flee the eruption, especially if it erupts in Pozzoli or if it erupts nearby. And if it erupts in the water, even a VI5 will trigger tsunamis. You're going to have massive waves hitting the shore, killing thousands of people. And if there is warning, say they determine, okay, this is going to erupt, we're going to have an eruption, we need to evacuate, you're going to have economic losses in the hundreds of billions of dollars. I mean, of course, it's going to pale in comparison to the coronavirus, but but the thing is, if people don't evacuate, there's a chance that this volcanic eruption might kill many more people than the coronavirus in all of Italy. And if it's basically going to be I'm talking not the worst case scenario, I'm talking about the most likely scenario. VEI 5. Not 6, not 7, but the 5. Remember that video they were watching? I think it was, go back to history. Let's go back to YouTube. That's the one. That's the video.
Some of the activities that volcanologists do in order to
this is what he was talking about.
and those are
This is only in the last 5,000 years. That is almost Vesuvian size. Vesuvius, I think, was about 1 to 2 kilometers of ejecta. This is basically Monte Novo, and this is basically, if you have something on this level, like if you have something at this level, you're not good. But if you have something at this level, people are going to be hurt. This is basically VI 1, 2, 3, 4, and this is basically very close to 5. This is like VI 4 to 5. Basically. You can have this level here, high level 4. You could have tens of thousands of people potentially killed if it's a very sudden eruption because of pyroclastic flows. If it's going to be a vertical eruption, which is, it's not going to be like, so even these eruptions can kill hundreds of people. Because this is, where was that eruption that he talked about? Yeah. This is Pozzolano. This is the 1538 eruption. Nobody died, but some buildings got destroyed. If you're going to have this level, that's already bad. Anything at 0.1 kilometers, that's already like, what, VEI 3, VEI 2 already.
Eruption which occurred in AD 1538, a very small eruption as you can see, but still an eruption like this one would be a real problem in the area, and that's because 500,000 people live inside the volcano, live inside Campi Flegrei. You can see here from this picture, this is all Campi Flegrei, and Campi Flegrei are bigger than that, and the same city of Naples is sitting inside. A large part of the city, not all the city, is sitting inside Campi Flegrei, okay? And this is Pozzuoli city, which is also very large. This is the Monte Nuovo eruption, the last eruption in 1538. You can see here it produced this new mountain. Monte Nuovo means new mountain, exactly that. And you can see how urbanized is the area around that. This is a picture showing the eruption in the 16th century. Still there were houses, towns, not the situation as today, of course. In fact, all the area here is heavily urbanized. There are about 3 million people exposed to volcanic hazard from 3 major active volcanoes, which are Campi Flegrei here, a caldera, Vesuvius, very famous Vesuvius volcano, and Ischia Island, which is also an active volcano, which erupted last time in medieval times. Okay, so it's 3 active, dangerous volcanoes and 3 million people living there, with a density of urbanization, which in many places is comparable to that of Hong Kong. So it's really a huge problem. It's probably the highest risk, volcanic risk situation in the world. What are those kinds of hazards that are expected when you have a volcanic eruption? Well, a volcanic eruption is different from an earthquake and from a tornado because the kind of the processes producing hazard and risk are very many and very different. You might have a lava flow eruption. You can see here depicted some lava flows, and that is a problem, but this is certainly the lowest risky kind of volcanic activity because lava flows are slow and you can just go away while they are coming. They destroy everything, of course, they very rarely kill people. But if you have an explosive eruption like the one that we see here, instead of having lava flows, you have a mixture of gas and fragmented magma. The fragmented magma is what we call pyroclasts, and that's pumice, volcanic ash, free crystals coming from the magma. It's a mixture of pieces of magma which are fragmented because of the very high speeds of ejection along the volcanic conduits. This volcanic ash can go up into the atmosphere up for tens of kilometers, up to 50 kilometers in very large eruptions, and then it's spread over by the winds. In Mount St. Helens in 1980, the eruption of Mount St. Helens produced ash that traveled eastwards, and after 1 month, they came back above Mount St. Helens. So they did the world tour. Okay. And the ash which is spread over into the atmosphere will fall somewhere, producing a fall of ash which accumulates on the ground, and that may create huge problems for the population and also cause the collapse of roofs. So it's a very dangerous source of volcanic risk. But the most destructive kind of volcanic activity is pyroclastic flows. This mixture of gas and ash can go up into the atmosphere if it becomes less dense than the atmosphere surrounding that. But in some cases can be denser than the atmosphere. So what it does, it goes up for a while, then it collapses down, and it forms avalanches of hot gas and pyroclasts, which are called pyroclastic flows or someone else called them density current, volcanic density currents, which is the same. And these pyroclastic flows can travel to speeds above 100 kilometers per hour.
There's basically two types of pyroclastic flows. There's the one that's caused by the lava dome collapses, like what happened at Mount Unzen in 1991, which killed several scientists and people researching the volcano. Well, yeah, some volcanologists. And you have basically the eruption column itself collapsing, which is this type of pyroclastic flow here. There's actually there was a volcano that erupted in Japan, a sudden eruption, unexpected eruption, and there was the pyroclastic flow of the volcano collapsing. Basically was the lava, basically the eruption column, it spilled over the sides and created major pyroclastic flow. It happened just a few years ago in Japan. I will quickly show you the video. This is the one. Shindake. Yeah, it's the one, Shindake. Yeah, you're gonna see it erupting very quick. So there it is. There's eruption. And look at that. Even briefly, you're gonna see what is the shockwave right there. The shockwave. And more shockwave. There's two shockwaves there because it wasn't one pulse. It was several pulses. And no, another pulse right there. And then look. Okay, here's the eruption column right here. See, it's even going into the clouds partway. And look what's gonna happen. You think it's just gonna go into the sky? See, part of it goes in the sky, and then look what happens. It collapses down. See, yeah. So see, right there. Pyroclastic density current right there. That is what you would call a eruption column collapse. And look, having major pyroclastic flow. I'm going to fast forward all the way. And see, and then it kind of retreats. But look, see all that fire there? That's it. And it went all the way up to about here. See? And then leaves burnt vegetation. Temperatures here were probably at least 600 degrees centigrade, at least. And you can see the rest of the column is still rising. And this is definitely a magmatic eruption. It's called Shindake. I'm gonna do some research on that. I'm just gonna go for 2 seconds. Shindake. And then 2015. And Shindake. See, that's definitely a magmatic eruption. That's no way that's geothermal. I mean, hydromagmatic. That is a fully fledged.
This is Super Cal.
That is a fully fledged magmatic eruption.
Agarrimashou! Sensei, 一回上がりましょう!
inches in the last 10 years. Yeah. This is in the last 5.5 years. Yep. It was slow. Now we're having rapid uplift. Really rapid. And it's not slowing down, it's just continuing at that rate. Rising 13 inches in the last 10 years. Well, it's doubled. Now it's 15 inches in 5.5. Let's do 10 divided by what, 5.5? 5.5 years. That's that much. And same time period. Now let's go to what, 15 inches in the same time frame. Doubled. Yeah, doubled. And copy. Divided. Ooh. Come on. Darn it. Darn it. No. Copy. Paste. Divided by this much. Copy. Almost doubled by an increase of a factor of 1.5. That's basically a 50% increase in uplift. That's how much time, that's how much more it increased. It's about 1.5. 2 would be 100%. So this is about 50% increase of the rate of uplift. Well, let's do percentage-wise. Let's do 80% increase. Plus 80%. Yeah, that's what I was thinking. Plus 50%. Yep, 50%. Exactly what I thought. Yeah. So yes, Captain Fligrai has. Hello? take a phone call. Back now. So yes, basically the Uplift Act, Camping Flegrei has more than I'm not say more than double, but it's increased by a substantial amount. And when they were saying when they were talking about the uplift there, they were talking about like from the 2000s through 2016 to here. They're probably talking about this period of uplift, and it seemed like it might be subsiding, and then it just really just took off. I mean, look at this. This is really scary. This is through what, February, I believe, and the uplift is continuing. I don't know if this quake is going to cause subsidence or even more uplift, or if it's going to make the uplift really rapid, like if it's going to do something like this, like if it's going to increase like almost vertically, like the uplift is going to be over the course of what, maybe a few days or weeks, then over years. Imagine if this uplift, imagine if we have uplifts like in the 70s and 80s and the 60s. I mean, like in the 70s and the 80s. Of magnitude not above 0.4. It's a inflation rate next is about 0.7 centimeters per month since July 2017, totaling more than 50 centimeters in total during the past 10 years. Yeah, almost 2 feet. Yep. So let me check any severe weather that's been going on. We don't have many oh my god. Okay. Oh god. This is gonna be a crazy windstorm in Dallas. There's winds in the cell. Let's see. The crap. Going away from the radar towards. There's some winds about 70 miles an hour in there. There's some 70 plus gusts in here. Let's see if there's any hail in this. Yeah, there's some hail, and it's heading right towards Dallas. This Dallas heading basically, it's basically making a beeline right towards North Dallas. Yep, I'm gonna say, I'm reading the warning right now. I haven't got to the part where they said what the threat is. The National Weather Service in Fort Worth has issued a severe thunderstorm warning for southeastern Montague County in north central Texas, northeastern Wise County in north central Texas, Denton County in north central Texas, Cook County in north central Texas until 11 p.m. Central Daylight Time. At 9:54 p.m. Central Daylight Time, severe thunderstorms were located along a line extending from near Gainesville to near Forestburg, moving south at 35 miles per hour. Hazard 70-mile-per-hour wind gusts and quarter-size hail. Source, radar indicated. Impact, hail damage to vehicles is expected. Except considerable wind damage. Expect considerable wind damage. Wind damage is also likely to mobile homes, roofs, and outbuildings. Locations impacted include Plano, Frisco, Denton, Louisville, Flower Mound, The Colony, Corinth, Gainesville, Highland Village, Lake Dallas, Sanger, Lake Louisville, Little Elm, Crum, Pilot Point, Argyle, Hickory Creek, Justin, Double Oak, and Shady Shores. The following, this includes the following highways: Interstate 35 between mile markers 468 and 503. Interstate 35 west between mile markers 74 and 85. Interstate 35 east between mile markers 453 and 466. For your protection, get inside a sturdy structure and stay away from windows. Yep. This is barreling right towards my friend's location. Girlfriend's location. Well, looks like part of the hail core kind of went away. Let me look at correlation coefficient. Nah, there's quite a bit of hail in there. There's definitely some hail spikes in there. I'm noticing some of the radar's having trouble penetrating part of the cell. Yeah, there's definitely hail in there. The hail core is just west of Valley View. Yeah, there's definitely hail in there. I would say this is going to hit Dallas within basically the next hour. It's going to hit Dallas. Based on what I'm seeing right now, it's probably going to head. It may actually end up going just slightly east of Dallas or right over Dallas. I think this is. Yeah, this is basically going to just slam my girlfriend's location really badly. And I think there might be some tornadoes possibly. There's a couplet. Oh my God, there's a couplet in there. Oh my God. There's a couplet in that thing. Jeez. You know what? I'm closing all these windows out. Uplift, 13-inch uplift. Okay, that's not important right now. This is basically... Forget about this. This is not... None of this is important right now. What's more important is people's lives are in danger now. Well, especially someone I know and care about. So, well, yeah. Alrighty, guys, so yeah, there's a couple right there. There's a couple right there. In fact, there's a couple couplets. There's a couple areas that might have some rotation. Here, just south of Valley View, and over here. So yeah, there's a couple areas of rotation. Radar, basically. It's basically right along the gust front too. And that's the scariest thing. It's that these couplets are basically right along the gust front. You're basically gonna have like these little rotational eddies along the gust front. I'm not talking about gustitos. Like you might get some brief touchdowns. And actually, there was a brief chance of a tornado that hit just northwest of Valley View. Jesus. I'm looking at the velocity data right now. It's just south of Lindsay and northwest of Valley View. I mean, look at this. Right over there. I mean, check that out. I mean, so far there's no tornado warning, which means that you don't think a tornado is likely, but there's some very destructive winds in this. Like, really destructive winds. Correlation coefficient. I'm turning on correlation coefficient. A possible tornado happened just south of Lindsay. Thankfully, no debris occurred. Yeah, these storms are really intense. University Park, Highland Park. Where's North Dallas, actually? North Dallas. Just trying to think where that is. North Dallas. Grand Prairie. Where's Grand Prairie? Of course, that's where the chips factory is, you know. Frito-Lays, you know, Lays. You know, Doritos are all made here in Plano, by the way. Highland Park. No. North Dallas. So basically, yeah, this storm is basically collapsing right towards her location. Dallas is going to get slammed by some really strong winds, especially the north side of Dallas. They're going to get slammed. Base velocity showing some really strong winds. work-life balance is going to get hit really bad. Denton, Texas is being hit by some really dangerous winds right now. And it's heading Denton. It's heading now towards Horneth, Hickory Creek, Highland Village, Double Oak, Carrollton. It's going to hit Carrollton very shortly. I'm going to bet in the next 15-20 minutes. Yeah, Denton. So it's heading towards the south part of Denton right now. So people in Shady Shores and Corneth and Oak Point and Crossroads should be getting into their south safe places now. You should already be there, right? You guys should already be in your safe places. Because this radar is about, 5 minutes old? So based on that, I think Crossroads should already be seeing really strong winds, even though it's not showing it. Denton, already, I think the worst is over. North side of Denton, I think the wind should be already calming down. But downtown Denton, you're about to be hit by some really, really strong winds. There are several episodes of strong winds coming in with this thing. It's not just going to be a single gust and it's over. It's going to be a prolonged period of some very strong winds and heavy rain when this comes through. There's going to be about a 10 to 15 minute prolonged, very strong wind event with this event coming through. Thankfully, the winds are weakening. I don't know if that's because it's getting closer to the radar and it could sense better, or it's because it's getting closer to the radar and the beam's lower. I believe. I'm looking at radar and it's still showing really strong winds. I'm looking at tilt 3, which is basically looking up to 7,500 feet and strong winds, even at those levels. Yeah, lower levels is not showing it. Yeah. Tilt 2. Strong winds. Yeah, Denton. Tilt 4. Tilt 1. So Denton is getting some really strong winds in the order of about 50 to 60 miles. Actually, yeah, Denton is getting some winds about 60 to 70 miles per hour. There's definitely severe winds in the Denton area. It's now heading towards North Dallas, but thankfully, some of the strongest winds have thankfully abated. And the storm is now gusting out. There's actually a gust front right now. And the strongest winds will actually happen about a minute or so before the rain comes in. There's a very strong gust front right now that's barreling right on Shady Shores. Shady Shores is about to be hit by some very strong winds. Even Ponder got hit by some strong winds. There's some secondary strong cells coming on the backside, which are producing some hail. But this cell, I don't think it's producing hail anymore. Well, just issued a new warning. They just basically issued a new warning. It's at 10:32 p.m. Wow, that was quick. At 10:31 p.m. Central Daylight Time, severe thunderstorms were located along a line extending from Sawyer to Lake Texoma, moving southeast at 40 miles per hour, or south at 40 miles per hour. Hazard: 60-mile-per-hour wind gusts and quarter-size hail. Source: radar indicated. Impact: hail damage to vehicles is expected. Expect wind damage to roofs, siding, and trees. Locations impacted include Sherman, Paris, Denison, Bonham, Van Alstyne, Howe, Pottsboro, Leonard, Honeygrove, Whitewright, Gunter, Blossom, Bells, Tom Bean, Savory, Ector, Deport, Dodge City, Bailey, and Knollwood. For your protection, get inside a sturdy structure and stay away from windows. And I think a new warning was just issued for Dallas. Yep, I think the National Weather Service is just about to issue a new warning. I think they're like a minute away. I always thought that when you listen to No Weather Radio, that's where you hear the warning first, then you see it on the app. It was actually the other way around. They already issued a special marine warning on my phone, like I saw the map, and then I got the alert that it was issued. I heard the same code, specific area messaging coder. Go, the three beeps you hear at the beginning, and then you hear the tone, the alert tone, and then you hear the message being played. So the you hear is basically, it encodes it. In fact, when you listen to it, there's different tones. It's not always In fact, if you listen closely, sometimes you hear different tones. Each tone encodes it for a different warning. A severe thunderstorm warning could be like or like, for example, when you dial a phone number, you don't just hear beep 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 beep. You hear different tones like beep 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 beep. Some people are trained to identify phone numbers just by what they sound like. Yeah. There are some people who are trained to do that, actually, especially in espionage or. Yep, it looks like the core of the storm is going to be heading northeast of Dallas. It's not going to be heading towards Dallas, it's going to be heading northeast. It looks like the Dallas area might actually skip the worst of it. And yes, there actually is some rotation just south of Pilot Point. There is actually a bit of a meso vortex forming.